Ladies and gentlemen, the conference will start in 10 minutes. Ladies and gentlemen, the conference will start in 5 minutes.
Good morning. Welcome to the 2024 Maccaferri Indaba. Welcome to Johannesburg. Welcome to Empress Palace. My name is Manglan Pillay. I'm your Master of Ceremonies Program Director. I'll be your host for the next 2 days. It's a real privilege to be standing in front of civil engineers, particularly civil engineers. I'm a civil engineer myself. When I once spoke to, how many other civil engineers here? Civil engineers, just up and proud, civil engineers. This is dominantly civil engineers here. Okay, the rest of you don't feel left out. We'll call you to the front, we'll pray for you, sort you out. We've got a fantastic lineup for you, but before I go into that, I want to do some house rules. The bathrooms are out through the main doors on your extreme right and on the left, and I'd imagine it's on the same on this side. I have not checked on this side, but certainly on this side there are bathrooms. In the case of an emergency, your exit points are out these doors, through the foyer, and out into the parking lot. But we trust that we won't have any emergencies. Welcome. We've got an incredible lineup for you today. Our first speaker for the morning is one of our honored guests, Mr. Nicola Faccioli, who is also the GM of Maccaferri for the Middle East and Africa business. Mr. Faccioli, if I could invite you to the stage. Won't you put your hands together for Mr. Faccioli?
Good morning. Good morning, everybody. I'm a non-engineer, okay? So don't feel left out. Okay, I'm going to give a presentation mainly. This is probably going to be the only presentation that is not going to talk about product, because my job is really to talk about people. So I think that by giving this, this is a corporate presentation that with the aim to explain you who we are, what we are doing, okay, but mainly how we're going to move forward the company in the future. Find it. Okay, so Maccaferri is 140 years old, and basically it goes back in the 1800s, and it started with a blacksmith, basically. And basically today what we are a leading global company, which basically we provide advanced solution geotechnical, and basically we like to not only sell product, but really sell brains. So we sell project. Can I have the presentation, sorry, on the screen? Back in 2018, when we were reshaping the company and rethinking about the company, basically we redesigned our vision and our mission. And basically today we like, in terms of vision, so to be a trusted partner in order to nurture the world of tomorrow. And in last day, when I was looking at this presentation, I have to say that from 2018, if you look at the product development, really embrace this vision and this mission. So basically, we try to pursue really the continuous improvement of our product, make our product smarter, make our product better in order to have a stronger product in the market. A little bit of history. So we started back in 1879. Raffaele Maccaferri was a blacksmith. Okay, so basically he had a company which was founded close by in Bologna. Bologna is basically in the north of Italy. And in 1894, he invented the gabion. It was a sack gabion, so it was not a square gabion as we know it today. And the first application was actually outside Bologna. There was a flooding, and the system was used as an emergency tool to avoid the city of Casalecchio to actually be flooded. From that idea, he developed the concept, and in the early between the 19 to 1940, he started to do the expansion, first in Italy, opening up different company, and so going basically to the gabion as we know it today, so the cubic shape. In the 1946 to 1966, basically what we did, we started inventing new products like the mattress and vertical walls. So we started to differentiate our solution for a different market and different sector. So moving from just hydraulics also to the infrastructure, so to the road consolidation. In the 60s, it was going abroad. So we try really to push the company outside just Europe, so in all the continents. So we started opening up mainly in Latin America, so Brazil predominantly, and Central America. And then we moved in East, so China and in India. In the late 96 is where basically we started differentiating. So geosynthetic started to come in our portfolio because there was a change in the market, so there was a need for something different than just a double twist. The expansion in the early 2000 was mainly driven by, again, consolidation in the legal entity outside in the world, and basically the rockfall, so new application. Today is I'm pleased to announce that last week we have been officially acquired by a new fund, which is Ambienta. So after a transition of almost 2.5 years to be non-Italian, because we were actually owned by an American fund, starting from last week, we're back being an Italian company, which is something, to be honest, that we are quite proud. So the new challenge, what is the new challenge? The new challenge is basically digitalization. How can we approach this evolving market? We see is changing daily. In the presentation that you will see in the next few days, you will see how we have started to bring IoT, so Internet of Things with product into our product, how we are actually integrating a different way of designing, how we are going in terms of R&D development in using artificial intelligence, because this is the world of today. So we need to evolve with the technology that it comes up. So what is Maccaferri today? Today, Maccaferri is we sell in more than 130 countries. We have basically a revenue. Last year, we closed at around 646 million euro turnover. More than 3,000 people, around, I would say, 3,400 people around the world. 20 factory, and we have around 72 offices in the world. 72 offices, for us, an office is not just a presence, but means that where we have local engineer, local support, because one of the key of our success is always been to be close to the market, be close to the customer, be there to support the customer, and try to work always together with the customer in order to really give the best practice in designing and using our product. So today we are here. We're talking about Africa. I'm very proud and to have a fantastic team here in South Africa. And we have a vision. We have a very strong vision for the next 5 years. Today, we have, last year, in 23, we served 35 countries in Africa, more than 30 million total turnover, around 70 people working in Africa for the African organization. We have one factory based in Durban, and we have 2 subsidiaries. We have a plan. We're going to open up 2 subsidiaries in Africa this year in 2024, one in 2025, where basically this will give us really a strength in terms of logistic support, but also, as I said before, to serve the market and be close to the market, because this is really what is the aim for the future. When we talk about digitalization, really, this is an example of the first time I saw this map. It was a handmade drawing in the 60s, okay? And it was used basically to explain how our product, where we were, which sector we were. This is a new map that you can find on our website that you can go and click on each solution, market sector, and it will explain which application we actually have for that specific, this is a soil consolidation. So basically, that specific sector. And this is just an example of how we want to make spread the knowledge of our product, and not only spread the knowledge of our product, but also to teach our customer also how to best use our product. We have, as you can see, at the beginning was just double torsion, geosynthetic, so it was like we were working on a very limited market sector. Today, we expanded and we are differentiating a lot. So basically, we have, in the last 5 years, we have a new, beside the three core business that you will see later in a slide, which are basically double torsion, GSY, and rockfall. Today, we have the tunneling division. So we work in tunnel. We work in aquaculture. So we do fish farm. We do product for defense system for the military. So we are really differentiating our product portfolio and positioning. Of course, we have to talk about mining. So this is just a list of our mining capability. And as I said before, I'm not an engineer, so I'm not going to try to sell you anything, okay? So my colleague will do this during the next few days, but these are just one of the points where we will touch base in the next few days in terms of the capability that we have in our mining, for our product that we have for mining. Our basically portfolio, so is double. So we started in the double twist, and so gabion, mattress, TerraMesh, so vertical walls, and this is still probably the base and the core of the organization. Even if, from a result point of view, geosynthetic, which is a much broader portfolio of product in terms of so NTO, that turnover actually overtook the double twist, we are still a metal guy, basically. And the geosynthetic is what really brought us in the future in terms of product, solution, and a mix of open up sector like landfill. And the geosynthetic is probably where we're going to be focusing also our effort in the near future. Rockfall, I'll, before taking this position as a general manager of Africa and Middle East, I was the general manager of the Italian operation, and Italy is full of mountain. So it's full of, we have the Alps, and for us, rockfall is a pillar of our solution. So the beauty of having such a difficult market is that that gave us the opportunity to really stress and our product, comprehend the limitation of our product, improve our product. So when we talk about continuous design, is really something that for us is an ongoing process. Elomac, Fabien will talk about Elomac, and basically it's a system which is an alarm system which actually activate and can give the opportunity to the public authority to understand if the barrier has been hit, and this for us is where we want to go with our product. So not only for the rough application, but for instance for the tunnel application, or even for the gabion application. So we're working on really how to make our product much more smarter and much more usable to the engineering society. Tunneling. Tunneling, I could stay here and talk to you about tunneling for half an hour because I'm also the head of tunneling division. So, but basically, let me say that tunneling, the approach that we had on tunneling is a bit unique because it's a division that is only 5 years old, but all the products that we are doing in tunneling are designed to improve the safety of the people that works in a tunnel. So we actually do either products that are designed to reduce the presence of people in the risky area of the tunnel, or speed up the process in order to mitigate the risk always in the tunnel. Tunneling basically is, excuse me, is a division which is mainly active in Europe and Asia, but the plan is to try to expand the division basically everywhere on a global base. As I said before, this is picture, I don't know if you can see it, but that is a fish farm, and if I, unfortunately it's very small, but consider that probably a man will be approximately about this size. So it's a fish farm which is located in the north of Europe for the production of salmon, and is one of the first 3 that will be installed in the next 5 years. And this is just an example of how we are capable of differentiating our product portfolio, but basically using our current product and just use it in a different way. Defense, we do basically system for the defense cell, which is basically a system for the army in order to create protection for the sensitive area, basically. And we distribute this mainly, predominantly all around the world in the critical area. Let's go talking about people, what I was saying before. For us, civil engineering is just a process of building the group of engineers of tomorrow. So we are continuously keeping students in our organization in order to form them, and this basically in order to give assistance to our customer when we are in the project phase, designing phase, in order because, and this is a funny thing because we have a mix of cultures, so you have basically the core figure of the company, which are a certain age. Consider that I'm old in the company, so today our average is engineering age is more in the 35 years old, and so basically we are considered the old of the company. And basically this is giving us a strong footprint in order to cooperate with the customer. We've been working a lot on software. So we have free software, which are downloadable in order to design a wall, in order to design a solution, rock solution, the geosynthetic solution. So we have a complete variety of software in order to support our customer and to work together with the customer in finding the optimal design. And this is a key matter for us because it's an investment, And we know sometimes people ask us, but why don't you sell it? No, we give it basically for free because it's a way of educating the market in using our product. And the more the people understand the best practice and the use of our product, the best is not actually is not just a selling pitch, but for us, having an installation which actually works is the best result. We have a product specialist basically in order to assist installation all around the world. So basically we try not only to design phase, development phase, but also the installation phase. In certain areas of the world, we did try to do installation, but I think that for us, our job is really more to educate the customer in using our product and assist them in order to use properly the product. One of the biggest efforts that we did in the last 10 years is being on certification. Not just because we like to define the specs, but mainly because for us, being able of give a standard, give a certification, a clear way and a transparent approach to our product. And this is a fundamental aspect and way to approach the customer. Lately, especially in the European market, you can hear a lot about EPD. EPD is basically a declaration about the environmental product declaration. So we state the carbon footprint of each product. So which means that you have to go through an assessment of the life cycle assessment in order to declare exactly how each product actually impacts the carbon footprint. In Europe, you can already see public tender, where basically if your product has a very low EPD declaration, actually facilitate, so give more points in the tender, in the public tender. So this is something that for us is really a key point of the future of Maccaferri. So we try right from the beginning, when we start developing and designing a product, we also look exactly at the value chain, so the supply chain, and also the life cycle assessment directly, because if the product it doesn't respond to certain metrics, certain target, we will not move forward on the product. So this became a key element for the future product. Also, then of course we go all the declaration on wire, on geosynthetic, and this is really because we want to be recognized as a leader, not only in the product, but also in the standard. For us, is a way of giving, let's say, trust, being trustable in the eye of the customer. So our commitment as a global goal, is really sustainability. So sustainability is try to have product with less material, which is less emission, longer design approach. One of the things when I joined Maccaferri, I gave a presentation in the Italian Senate, in the Chamber of Infrastructure, and it was about gabion. So in Italy we have the Gabion Producer Association. At the time I was president of the Gabion Producer Association, and one of the points about the gabion is the durability. So basically it's a product that we have certain installation. I mean, I remember I gave a presentation and it was about a job site that was done in 1945, basically in Florence, outside in the Arno River. And if you go there, the materials still work. Okay, so the materials still actually address what it was designed for. And I always thought, okay, you know, we are making a product which lasts 80 years. So from a business point of view, it doesn't make sense, you know. But really, this is one. For me, is one. The reason why we still believe that the DT has a very strong message from an environmental point of view is that as a durability and from a sustainability point of view is seriously long. Production of clean energy. So we are very focused right now on solution for help or support, like when there is a wind field production or solar field production. So we do have the design solution for soil stabilization and support the customer in design. So reuse of woven material. So this is something that, again, when you look at the EPD of a product, the fact that you are using recycled material today is something which really impacted the score of the product. My background is not, as I say, I'm not an engineer. My background is in the food industry. And in the food industry today, very rarely you have a PET bottle which does not contain at least 30 to 35% of recycled material in it. So the technology is there. It's just a matter to use it, okay? So protecting wildlife, we are very committed in working with the organization in order to safeguard. There are special projects on protecting animals and wildlife in general and in certain projects. Not only protecting wildlife, but protecting people. This is in Marseille, the promenade, unfortunately, where there was the attack many years ago with a truck. So we have basically safety device which are spin-off, let me say a spin-off from the rockfall protection element. So which are devices that actually help us protect a certain downtown center area in order to avoid that car can enter or crash into it. So the other thing that we are really committed as a company is basically work with the local community. And this is something that we are doing, and we're doing in terms of supporting the local community. We have a lot of activity around the world, which start from schooling to the university, so really to work together with the community in order to grow and to grow together. As I said at the beginning, you know, for me, my job is really working with people and managing people. And I think that when I look at the organization, especially in South Africa, I see a very young generation of motivated people, and I'm really looking forward to work with, first of all, thank you very much for coming and for giving me the time. I thank again to give me the time to speak today, and I hope you're going to have a very good days. Thank you.
I want to especially acknowledge Mr. Nicola for speaking to us this morning, especially that I know that you're on your way out, you're flying, so hence the quick introduction earlier. We wish you well on your journey, and we hope to meet each other again. So in our company, we have some incredible human beings who have accomplished much. On the Maccaferri leadership I want to acknowledge Mr. Gan Lucken. Gan, I don't mean to put you on the spot. I want you to stand so people can see you. Mr. Gan Lucken, the GM for Maccaferri Africa. We also have Mr. Fabien Gazado, who is the HOD for Rockfall Maccaferri. He will be speaking to us later, so you will get a good sight of him. Moreno Scott, HOD for Geosynthetics Maccaferri, and Mr. Jaya Krishnan Vital, the Technical Manager for the Middle East. You will meet some of these colleagues as the program unfolds during the course of today. We also have in our company somebody I am truly honored to introduce. He is our keynote speaker for the morning. He is the CEO of Dynamic Fluid Control, which is the largest South African-owned industrial valve manufacturer with wholly owned subsidiaries in Australia, Brazil, Finland, and in the US. What's phenomenal about this particular business, DFC, is that the products are local South African products. Before joining DFC, he was the managing director of the South African Mint and a board member of the South African Banknote Company. He started his career as an engineer at Eskom Rotec Engineering. He joined SAB Miller, where he occupied various roles in manufacturing. He is currently on the board of the Steel and Engineering Industries Federation of South Africa, SIFSA, and he is also the chairman of SACIC, which is the South African Capital Equipment Export Council. He's got a BSc in engineering from University of Cape Town. We forgive him for that. I'm a Witsi. He's got an MSc in engineering. He finally came to his senses, did that at University of Witwatersrand. He's also got an MBA in finance, also from UCT. And to prove his capabilities, not that he wanted to prove his capabilities, but to show us his capabilities, he's also got a Bachelor of Arts degree in philosophy from Birkbeck University of London. He will be talking to us about how mining underpins the economy of South Africa. It is truly my honor and my privilege to introduce you to Mr. Tumi Tsetlo.
Thank you, Manglen. So from 2025, I'm going to be a Ferrari fan. So I think I'm in the right place. I follow the drivers. So where Lewis Hamilton goes, I go. Good morning, colleagues. It is a great pleasure for me to be here. I'm really pleased to stand in front of you today. I'm going to learn a lot in the next 2 days. I'm hoping to be here for the full 2 days. And what I understand is that we're going to be diving into the discussion around mining, construction, really as it relates to safety and stability and those kinds of things. I am deeply honored to be addressing this distinguished group of people, engineers in the room, lots of you guys, influencers, decision makers, and people in the geotechnical industry. Just by way of introduction, I am Tumi Tsetlo, the Group CEO of Dynamic Fluid Control. My personal journey began in the township of Seshego in Limpopo. And when I was there, I had ambitions of, one day growing into a person of significance in our country. And over the years, I have evolved from being an aspiring engineer and become involved as a business leader over the years, and now navigating the complexities of the industry that I'm in and seeking to contribute to the development of South Africa. When I was in school, I wanted to become a civil engineer. But after I finished high school, I was forced into electromechanical engineering. And I remember 2 years into my degree thinking, I am so grateful that I'm doing electromechanical engineering and not civil engineering, because it seemed that all the killer courses were in civil engineering. And so I was very happy to be away from it. But when I look back 30 years into my career, I realized that actually civil engineers are the guys that actually run everything. You guys, it turns out that I actually chose the wrong degree after all. I wish I was a civil engineer. As we gather here today to explore the dynamic landscape of mining and construction for enhanced infrastructure and safety and stability, it's impossible not to acknowledge and admire the remarkable legacy of Maccaferri, our host, who have steadfastly contributed to the industry for an impressive more than 140 years. At DFC, we find ourselves trailing behind with 76 years, and we aspire to emulate the success that Maccaferri has achieved and contribute positively to the industry for many years to come. At DFC, we envision a world where safety and stability are paramount in every mining and construction endeavor. As a manufacturer in the mining and construction industry, our mission is clear: to partner with our customers to provide innovative valve solutions that not only meet but exceed industry standards, ensuring the safety of workers and the integrity of the mining plants. At DFC, we take health, safety, and environmental management very seriously. We understand that our work extends far beyond the confines of our factory. It is a testament to our commitment to safety, quality, and innovation. Quality is at the forefront of everything that we do at DFC, from adhering to rigorous testing protocols to conforming to the higher standards such as water regulation standard, what we call the RES, ISO 9000 and ISO 14000 and 45000 certifications, the National Sanitation Foundation certification, which ensures hygiene standards for valves in water. We leave no stone unturned in our pursuit of excellence. Our commitment to quality is reflected in our consistent delivery on time, met with precision. In a globally competitive landscape, building credibility is essential. At DFC, we understand the importance of establishing trust and reliability in the eyes of our customers. Through transparency, integrity, and steadfast dedication to customer satisfaction, we have earned our place as a trusted partner in the industry. DFC operates in the valve manufacturing space, which is part of the steel and engineering sector. This is nothing close to the geotechnical industry that you guys are in. Yet, we have in common that mining and construction are our customers. So we're all exposed to the same industry trends. Our adaptability lies in our ability to recognize the challenges in these industries and uniquely tailor our responses to each sector. Climate change is a big driver in both our businesses. Sustainable environmental practices are very important in both our businesses. Not only is it important to our customers to know that we meet all the required ESG protocols, but it's also important to them to understand how we, as their partners, will contribute to their quest for good to become good corporate citizens. Only good corporate citizens can help other corporate citizens to also be good. My sense is that Maccaferri is very well positioned to be the kind of partner that mining in South Africa and in Africa will need as one of their many ESG partners. The most obvious aspect that positions Maccaferri as a partner for the mines is your heritage and experience in rockfall protection and mechanically stabilized earth walls. However, I would like to suggest that your experience in designing solutions that are deliberate in their aims of preserving and beautifying the environment positions you as the ideal partner to help maintain and restore the natural characters of the areas that are being mined. Mining is not only has to maintain safe working environments and maintain the mine's infrastructure in a safe condition, but increasingly, mines will need partners that can help them to restore the natural sense of the areas that have been mined. This is important to make sure that the areas that have been mined can be easily restored to their natural state as far as possible. Mining remains the key driver of industrialization in South Africa. All other industries grow from the momentum created by mining. South Africa's mining industry has been recognized the world over as the source of many innovations. For example, we have been known for pioneering viable mines at the deepest levels of the earth. Such innovations were made possible in partnerships with industrial players. Over the years, our pioneering role has subsided somewhat. We are not longer the ones that are known as leading so much. South Africa's economy shifted also over the years towards services, especially financial services. However, mining remains the driving force of industrial activity. Mining has remained the main driver of industrialization in this country. In my view, what I've seen is that there are two factors that drive the mining economy in this sense. We've got the global commodity prices, and we've also got investment in exploration. It is obvious that with regards to commodity prices, South Africa is exposed to the global trends. One has to always take a long-term view of these, since commodities experience major business cycles. Different metals will go through cycles when they fall in and out of favor over multiple years. And right now, PGMs are largely out of favor. We're therefore expecting most PGM miners to focus a lot on cost-cutting and or delaying major spending on new projects. Just yesterday, we saw an announcement from Anglo-Plat that they are downsizing by roughly 4,000 people. Tharisa Mine has delayed a big project that they were supposed to do recently, and Impala Plats and so on. There are many challenges. This clearly will drive competitive pressures for suppliers of mining services and goods. Suppliers that are geared towards partnering and finding innovative solutions to their miners, for their mining customers, are the ones that will find opportunities to thrive. In this environment, it becomes tempting to resort to the lowest common denominator, which is to lower your prices, i.e. participating in the race to the bottom. But alternatively and preferably, as a supplier that is focused on partnering with your customers, you can double down on the key message of understanding your end users' main pain points and offering solutions that help them to eliminate or reduce these pain points. Developing the ability to collect the intelligence that helps you to develop such solutions must become a core competence. Although the environment is tough to operate in, it does not mean that there will not be opportunities to delight and retain customers. What is currently not great in South Africa's mining outlook is our exploration activity. The mining houses of all sizes have been vocal about how the government has not made it easy to invest in new exploration projects in South Africa. The absence of a working cadastral system has been cited many times as the reason why exploration investments in South Africa has not kept up with international trends and with exploration dollars in other African countries. There is hope, since a new system was announced in the recent weeks by the Minister of Mineral Resources and Energy, and he repeated this message at the Mining Indaba in Cape Town 2 weeks back, that South Africa has commissioned a new system to be built and launched in the next 12 months. In anticipation of the system being implemented, mining houses and the mining community in general are finally beginning to believe that we can expect some investment to come back into South African exploration. Exploration gives us hope that there will be new mines in our future. The importance of mining in Africa is demonstrated by how much the rest of the economy is reliant on mining in order to sustain their revenues. While mining's share of the GDP is measured at the primary level, a look at the secondary effects of the mining industry shows us that mining as an activity has driven demand for materials that have to be delivered to the mines and forms a further significant component of those businesses' revenue streams, and thus the secondary effects to the GDP. In the case of dynamic fluid control, between 60 and 80% of our revenues are derived from customers in mining. The rest goes into other sectors of the economy, such as water and other processing plants, chemicals, and so on. However, when we report our activity for classification purposes, we report it as part of the steel and engineering industry and not mining. So what is not clearly visible is just how much mining is the engine of our industry. Those of us that are inside the steel and engineering industry know very, very well that mining is the key driver, and we have a full appreciation of what mining means to us in South Africa's industrialization. My experience is obviously in the steel and engineering industry. However, you can imagine and expect that mining as a primary industry has tentacles that extend into many other industries, such as financial services, as I've already said, such as food production, such as construction. And in your case, civil engineering, we know just how much reliance mining has on your work. No project can be conceived without the involvement of civil engineers. You guys are found right at the center of all the projects, making decisions about how such projects are to be carried out. Civil engineers are the gatekeepers of who gets in on projects and who does not. For a long time, mining has been classified as a sunset industry, so much so that before I joined this industry, before I joined DFC, I never imagined my life could be so intertwined with mining. I also believe that mining is a destructive industry that does not respect the environment and does not respect the communities in which it operates. Some of that criticism has been valid. The advent of ESG in mining and other resource-intensive industries in general has provided sufficient evidence that mines have not always operated with the right level of responsibility. But all of that has now changed for the better. Responsible mining is no longer an option. It is the license to trade. All mining operators must extract minerals in a responsible manner that secures the long-term health of the environment from which the minerals are extracted. The benefits of mining can no longer just accrue to the capital providers, but operators must ensure that a wider set of stakeholders also benefit. Host communities are now integral to the objective setting processes of the mines that they host. Governance processes are no longer an afterthought. Processes must be implemented that make sure that the benefits of mining do not only accrue to the shareholders, but also to a wider set of stakeholders. including the communities, while also making sure that the interests of shareholders are sufficiently protected. In more recent times, say the past 10 to 15 years, discussions around critical minerals that are required to drive the adoption of renewable energy around the world and the manufacture of equipment for the digital economy have taken center stage. It turns out that in order for the world's climate change agenda to be delivered, we must find new deposits of these minerals. To achieve the United Nations Sustainable Development Goals, we must find new deposits of these minerals to be mined from out of the earth. If we don't, then our goals of managing man's contribution to climate change, for example, will not be met. Our goal of building a more inclusive world will not be achieved. Already, demand for these minerals outstrips the supply. And if new sources are not found, then we will not be able to keep up with the demand for new batteries, etc. Currently, the world's largest deposits of cobalt are in the DRC. But that is a status that may actually be abandoned in the future, the same way that it happened in South Africa with gold. Today, South Africa no longer sits on the top spot of gold producers. China, United States, and Canada have overtaken us. They found new deposits of gold, and they are now exploiting them. They are sitting in higher positions with regards to those minerals, as was previously the case for South Africa. Just 2 weeks ago at the Mining Indaba, the Minister of Mineral Resources and Energy announced that new deposits of some critical minerals have been found in the Northern Cape, in KZN, in Mpumalanga, and in Limpopo, namely lithium, phosphate, and coltan. That announcement has put some optimism into future expectations of new mines in those regions in the years to come. With that announcement and the implementation of the cadastral system, we can expect to see more exploration dollars starting to flow into South Africa again. Another announcement was made by De Beers that they have found new deposits of diamonds in Angola, of all places. For the longest time, we knew that Botswana had the world's largest deposits of diamonds, but De Beers' investment in exploration appears to have paid off and uncovered a new investable deposit in Angola. So this definitely does not look like a sunset industry. Just because an industry does not grow at double or triple digit rates of growth leads some people to mistakenly believe that an industry is in a death spiral. I think that the opposite is true for mining. The most glaring challenges facing the mining industry in South Africa are well known and well documented. The shortage of electricity, which has ensured that South Africa does not achieve its economic growth potential. Logistics inefficiencies of Transnet that has led to lower mining output levels. By some measures, by up to 15% of potential mining revenue has been lost per annum. Water is well on its way to becoming a problem on the scale of load shedding. And as if that was not enough, the lower prices and demand for PGMs, driven by lower economic activity out of China, and the lower demand for internal combustion engines is also affecting the mining industry. The internal country challenges that we face, we must find resolution in order for our economy to reach its potential. If there have been any lessons from load shedding, is that the commercial markets hold the keys to finding the solutions. Over time, the key lies in recapacitating the state with the right engineering and technical skills, especially at the municipal levels. In the medium term, the commodity supercycle that we experienced over the last couple of years and decade has slowed down. We have seen how China has not remained the demand driver that it used to be prior to the COVID pandemic. This has resulted in all manner of pressure on commodity prices and lower demand for commodities. When China was building factories at unprecedented rates in the 90s and the early 2000s, They installed massive amounts of capacity to process minerals and produce manufactured goods to be sold at really low prices around the world. This was the case in all types of industries, but the steel and engineering industry was particularly affected by this trend. My apologies, my notes just disappeared. Got them back. As I was still talking about the effect of China, that the steel and engineering industry was particularly affected by the way that China was building out in the earlier periods. They built capacities that were many times what was actually the case before they came along. Currently, China has 1.1 billion tons of steel production capacity installed. It is followed by India, that has 140 million tons, and the US only has 120. Compare that to what we make in South Africa. Our biggest steel manufacturers, our steel giants, only have capacity installed of 6 to 8 million tons. Depending on who you ask, it's either 6 or 8 million. We are just a drop in the ocean. And as someone once said, China makes in one day all the steel that we make in 1 year. By so doing, the Chinese also push down everybody's prices. So now with demand no longer there and China slowing down and no longer having the demand that they used to have for all these minerals, for all these commodities, this is having an effect of suppressing demand and prices for commodities, which has affected a country like South Africa. We expect to see a new normal of demand level being established in the market over time, but I'm not qualified to speculate exactly what those normal levels are. But I think there is sufficient consensus that commodities go through cycles and businesses have to position themselves to ride those cycles and be able to remain in business through the ups and downs. In the long term, we have seen that these cycles generally trend upwards. The trends will continue to be there over the long term, and mining for these specific materials will remain robust for long periods of time. I would like to close off my presentation by expressing my absolute appreciation for the invitation to speak at this conference that's going to be held over the next few days. When I was requested to speak, I was not exactly sure what I would have to talk about, given that I'm a bit of a new person in this industry, especially to a big crowd of civil engineers, and also find a topic of relevance. And let's also be honest that I'm not a mining person. I'm merely somebody that works in the mining value chain. However, I am thankful that I accepted the invitation. Mining affects all of us, and it is imperative that we understand how that industry will affect the fortunes of our businesses. I attended the Mining Indaba for the second time this year. My impressions and ideas around mining as a key lever and key driver of industrial activity in this country were shaped and reinforced over and over and over again by what I saw there. As people that rely on mining to absorb our industrial products, we must always seek to understand the dynamics that drive that industry and how we can better serve it. To that extent, I believe that just as mining is relevant to me and my business, it is also very important to your organization. I would like to wish you well in your endeavors to make progress in your services to the mining industry. and that you may continue to build on your past successes and continue to be a part of the drive to innovate and make mining better. The quest to make the mining industry a more responsible industry overall, whether it's in regard to looking after the environment well, or creating better, more sustainable operations for the communities in which they operate, or part of making sure that there is sufficient compliance in line with government and regulatory requirements. In closing, I urge you to recognize the universal significance of the challenges we face and the opportunities that lie ahead. As we navigate the ever-changing landscape of geotechnical industry, let us remain steadfast in our commitment to safety, stability, and innovation. Thank you.
Thank you. Good show. Thank you, Mr. Tsetlo, for the insights. Incredible opportunities for young people in our industry, incredible opportunities in Africa. China is still a player, but things are slowing down. Thank you so much for that. We wish you well in your leadership role in business as well as in the South African and the African journey. As Tumi was speaking, I remembered when my first association with Maccaferri was. I was a graduate engineer. It must have been 3 months or so after graduation, and I was working for a company, and there's plenty of geotech engineers, so you know what trial pit testing is? Does anybody know what trial pit testing is? So trial pit testing is when you, so just follow this is quite important to what I'm saying. It's an excavation of a hole. It's probably about a meter wide and about 1.5 to 2 meters long. And at that time, it was about 2 meters deep. That's 6 feet deep. So I was responsible to go and do a trial pit and look at the formations in the 2 meter zone and look at where pebble markers are, you know, what the geotechnical formation was at the 2 meter level. Now, I was excited because I was a graduate and I'm getting to do real geotechnical engineering work, 3 months. So I had blue jeans, white shirt. I was in the hole, so the excavator came, did his job. I went in. And just for the sake of being a geotechnical engineer on site, when I got messed, I messed myself some more so that I looked the part. And I had a white cricket hat on, which had marks on it as well, soil marks on it. And I was so excited. I also had a new phone because they gave one to me at the office. And in Tabazimbi, this is where this initiative was happening. So I asked the excavator driver to take a picture of me in the hole. And he did such a fabulous job. When I took the phone back, I texted it to my mother, who texted it or who called the ayah next door. Now, for those of you who don't know what ayah is, in the Tamil language, it is a grandmother, like how we would say Goko in our vernacular, or Oma in Afrikaans. So, and the ayah was about 75 years old at that time. So my mother gave this picture to the lady, to the ayah. The ayah looked at it and she said, "This boy, he went so far to Johannesburg to study for 4 years, and look at him now working in the graveyard." With that, ladies and gentlemen, we will be released for a tea break. I'll see you in 15 minutes. Welcome back. Welcome back. I really am delighted to be in the company of some of the old colleagues that I was associated in the previous life. I just had the pleasure of meeting Mr. Curry, who is here on carrying the brand of IMISA, Institution of Municipal Engineers South Africa. It's a pleasure to see him, and I'm hoping to see other colleagues, captains of industry. I was told that SAICI would have representation here, and CISA was also going to be represented here. These are formidable bodies in our sector. I hope the tea break has served you well, and we can continue with the rest of our program. On our schedule, we are doing quite well for time, even though we're probably about 10 minutes behind. On our schedule, our next speaker, who is also an executive at Maccaferri, is Blaise Jacob. Blaise graduated from UKZN in 2014 with a BSc degree in civil engineering. And after a year with Eskom, he joined Maccaferri in 2015. So there's no finger pointing because he left in 2015. We don't know who started the problem. He participated in the Young Engineers program at Maccaferri in Bologna, Italy, and I'd imagine it was a wonderful experience to travel there. In the last 10 years or so, Blaise progressed from being a graduate to a sales engineer, to a project manager, and now head of sales for some countries in the SADC region and in Central Africa. He is also responsible for the Rockfall business unit for the South African subsidiary. Blaise, it's wonderful for me to read this introduction for you. He's going to be talking about, he's going to be introducing us to rockfall mitigation products that Maccaferri offer. Put your hands together for Blaise Jacob.
Hello, good morning. Thanks for the lovely introduction, Manglan. I really appreciate it. I'm very glad to see some familiar faces in the audience. I'm also glad to see some new faces. So I'm very confident that we're going to learn from each other, we're going to get to know each other, and hopefully we can do some work in the future, near future, far future. If we do cross paths again, it will be well worth it. Thanks for the very generous introduction, Manglan. I also want to say I just found out that the average engineer age in Maccaferri is 30 to 35. I'm 33 years old, so I'm the average of the average. So to help me, I don't know if I'm young or if I'm old, but I'm transitioning now, so I got the honor of presenting for you guys today. So my presentation is going to be quite introductory. It's very basic. It's just an introduction to all the products that we offer so that you guys have an idea when my colleagues speak later more on the technical side and the application, so you guys know what we're speaking about. So we're going to just go through, I know that Nicola did touch on it as the global level, but I'm going to touch on it from a Italy to South Africa transition. Examples of rockfall problems that are experienced in the industry, why we need rockfall protection, which is very important, type of solutions, the products we have from a drape mesh type point of view, barrier systems, embankments, Mac Armor, and Hello Mac. So those are basically our portfolio of products that we can offer. So As Nicola mentioned, Maccaferri started in Italy in the 1900s. They started off with 3mm wire, and these products obviously evolved as the industries evolved. Gabions were developed. They used Reno mattresses in the River Reno in Italy, and as Manglan said, I got to visit there. I can confidently say that those gabion structures are still intact after 100 years. Obviously, the wire coatings and stuff weren't so advanced, so there's a lot of rust, but the primary structure is still there. So we can confidently give 100 years of design life on our product with real-life examples. River and Sea Gabions opened in South Africa as a Maccaferri branch. So in South Africa, we're like 67 years old at the moment, so we've got a long historic relationship with the civil engineering market in South Africa. After Gabions, we've developed TerraMesh and green TerraMesh systems, which I'm sure you guys will see much more of tomorrow. We've improved the coatings to become more efficient, more cost-effective, more environmentally friendly as well. And we built a very big 24,000 square meter factory in Tongaat in 2010. That factory in Tongaat services basically the whole of Africa with the supply of gabions and some rockfall products. So where we are right now in South Africa, we have our factory on the coastline, just slightly north of Durban in Tongaat. We have our head office in Johannesburg. We have a distributor in East London and Cape Town. So these distributors have warehouses where they keep stock for us. So wherever you are in the country, stock is always easily accessible. So let's go straight into it. Examples of rockfall: you can get falling of large boulders along roads, railways, close to infrastructure. You can get rock slides. Sorry if I'm blocking you. You can get debris flow, and obviously in Italy, they've had major debris flow historical tragedies, and that's why rockfall has become quite prominent in those areas. In open pit mines as well, which is what we're trying to get more into the safety aspect of the mining industry, especially in open cast mines. So why do we need rockfall protection? Rockfall protection is becoming a very big growth sector for us, and I think in general in all mining sectors. The reason is that the risk attached to rockfall is very, very high. You can have the loss of life, loss of infrastructure, etc. So why do we need rockfall protection? One is for public safety. Primary reason is to save people, so there's no fatalities and injuries, workers in the mines, etc. Infrastructure protection, to protect railways, roads, even houses and hotels, etc. Traffic continuity, so this also becomes important because if there's major rockfall event and municipalities have to close major roadways, it becomes a traffic issue. So for traffic continuity, it's very important. Environmental protection as well. As we becoming a more and more green-orientated company, for environmental protection, the rockfall is very important, as if it occurs, it can destroy vegetation, disrupt habitats, and cause soil erosion. Maintenance costs, regular maintenance to clear debris of rockfall. If we have the protection, it will mitigate the maintenance requirements. And of course, protect property values. If an area is very prone to rockfall problems, then the property values can decline. And there's also legal consideration, sorry. So with rockfall solutions, there's two types of systems that we consider, and all systems can fall under either these two headings, or you can have a combination of both. So an active system, it prevents rocks from falling at its detachment area. So basically, you are securing the rock at its point of origin before it falls down. With a passive system, this more allows the rock to fall, but you can control the pattern or control the manner in which the rock falls, and you can control the end destination. Okay, so some solutions do combine both. So I want to show you the simple drapery solution and the secure drapery solution. Okay, one simple drapery is a passive system, and secure drapery is an active system. So what's really the difference? The simple drapery, you just anchor at the top, and this primarily is to hold the weight of the mesh. The mesh runs down the slope, and at the bottom, I don't know this, sorry, the laser doesn't work. At the laser, you can either anchor it at the bottom, or you can dig a trench to allow the rocks to fall into that trench. So as an example of a passive system, the rocks still fall, but we are controlling the destination of the rock. With a secure drapery system, we put anchors or soil nails intermittently into a matrix depending on the design, and rocks are unable to detach from the slope. So it stops right there, and that's reinforcing the slope. We have something called MSC embankments, which is mechanically stabilized earth embankments. And this is used to catch very high impact loads, which you'll see later on. And we have rockfall barriers, which also catch high loads. It's also a passive system, but the energy capacity is between 500 to 8,500 kilojoules. So let's look at the simple drapery system. The objective is to drive the unstable debris at the toe of the slope. It reduces the energy and the velocity of the blocks. The main issue with this is to calculate the top supporting system cable and anchors. So I think you will go further into the design over the course of the day to understand how to calculate the strength requirements for the mesh and for the accessories as well. The main advantages is that there's no need to stabilize the rock slope and low maintenance required. Of course, there is some sort of maintenance required. If the trench you dug becomes full, you'll have to do maintenance periodically depending on how frequently the rocks do fall. So this is an example of a simple drapery system along a railway. I apologize if I'm blocking anyone. But as you can see, the net is just draped at the bottom so that rocks cannot get onto the railway line. For the simple drapery solution, we generally recommend with the standard that the anchor should not be spaced less than 1.5 meters from the top. And this is an important factor, just to note that the anchor takes the weight of the mesh. Anything less than that, it can cause some problems of erosion and destabilization. Moving on to the secure drapery system, it's a combination of wire mesh, cables, cable panels, and anchor nails. So the objective of this is to provide rock stabilization and prevent blocks from falling at its origin. So this is the active system. The issues that can be considered during the design are calculate strength requirement and the allowable deformation of the mesh, to calculate the matrix of the anchor spacing, and to calculate the anchor length. So with this drapery mesh system, it starts off as steel wire, which we get into our factory. This is mild steel. It is coated with zinc, okay? We have two options, actually. One is fully coated with zinc. The second option is called Galfan, which is 95% zinc and 5% aluminum. So the aluminum acts as a retarder to corrosion, so it has a much longer lifespan than just zinc galvanized. And over and top of that, we add a polymer coating, which is trademarked. We call it Polymac. We also do it in compliance with the codes. So the zinc coating is Class A as per SAN 675. So it's the South African national standard. If I'm not mistaken, I think it's 265 grams per square meter. It's somewhere in that region to make it a Class A wire for 2.7 millimeter wire. From the wire in our factory, we make it into a mesh product, but we do a double twist. So if you look on the left, you'll see the wire is double twisted. It's actually 2.5 twists. But the advantage of this over single twist chain link mesh is that if it breaks at that point, because of the durability of the double twist, it does not unravel. So the breakage point stops there and it doesn't continue into the rest of the product. I beg your pardon. With the single twist mesh, if there's a failure, it sort of unravels kind of like a zip. Okay, and it's made into a mesh. I'm not sure if you can see it here on the right. We make it in rolls, so it's easy to transport. And it comes in various sizes, generally like 3 meters wide by 25, 50, 75 meters long. So, so the first product is just normal netting. So it's a double twisted netting that we can use for low capacity or temporary support, which we've just done recently, temporary support for a project in Zambia for Kariba Dam. From there, we make a product specific for the rockfall environment. It's called Steel Grid HR. So Steel Grid is a mesh that's a composite of the double twisted mesh with a high tensile steel cable rope that's intertwined into the mesh during the manufacturing. This offers a very high tensile strength and punching resistance at low strain. So how do we name these products? So between these high tensile ropes, let's call D the spacing. Steel Grid HR 100, it has a spacing of, I beg your pardon. It has a spacing of 1 meter, so the steel ropes are every 1 meter. The tensile strength is about 83 kilonewtons per meter, plus minus 5. For Steel Grid HR 50, the spacing is 50 centimeters or half a meter, and that's a little bit stronger because the rope is quite closer together. And then you have Steel Grid HR 30, which has always been our strongest product. The spacing D is 300 millimeters, okay, with a tensile strength of 180 kilonewtons per meter. We found that in the market, there's also the requirement for even higher strength of mesh required. We have recently started designing and manufacturing and certified Steel Grid HR 20, where the spacing is every 200 millimeters and the tensile strength goes up to 255 kilonewtons per meter. The next drapery product is something that we call an HEA panel, and this is a high energy absorption panel. So this combines high strength features of the wire rope that's with a steel knot. The knot is made by 2 bindings, each one obtained by looping a pair of steel 3 millimeter wires coated with Galfan. So you guys know what's Galfan now. The 2 bindings tightly envelope the ropes crossing each other. The panel is made of square meshes manufactured with 1 rope, closed by a pressed aluminum ferrule. Some accessories that we give to the mesh, because it can't just be the mesh by itself. We have HR rope grips, which we also call HD clamps, and this is used for the connection of ropes to the crest or to the mesh panels. We have something called a link mesh connector, which we also call a lap link. There's a rockfall stand outside, so there's some samples of these things as well. So the link mesh connector is used to connect adjacent mesh panels. And we have anchors and anchor plates that complement the mesh products. So if we can just summarize, we have the DT mesh, which we use for very low requirements or temporary support. We have Steel Grid HR 20, 30, 50, and 100, which is quite common because we manufacture this locally. So it's 100% steel content manufactured locally, which is a big advantage for us. So our, I see Tumi knows it well. So it's manufactured locally, so it's a big benefit for us. It means much shorter lead times, more efficient on our pricing, etc. Then we have the HEA panels, which is, it can have a little bit of a higher punch resistance. However, the apertures can be quite big. So the apertures are sometimes 250 by 250 up to 400 by 400. And because the apertures are quite big, we sometimes use this in conjunction with the DT mesh to take care of the smaller rocks. Okay. Then we're moving on to another passive system. So this is called a flexible barrier system. It's a protective structure that's installed in areas where there's high risk of rockfall, and the barrier, this thing is moving by itself. The barriers are made of cables and mesh, which are anchored to the ground and steel posts. The main features, this is going very quick. The main features are the interception structure, which is also known as the screen, I could say. It's just going very quickly. It may have support structures, connection components such as ropes, shackles, clamps, energy dissipators, etc. And these are all quite important factors in the barrier system. Maccaferri supply it as a full kit. We supply all the components for the rockfall barrier. We are also able to give you installation guidelines, some support on site, and design support as well. We also do full-scale testing. We do it in Italy, which you'll hear about more from my colleague just after me. So the European Organization for Technical Approvals, this has defined measures of what should be involved in the test methods, and all our barriers are approved, and we have certificates to back up the testing, which were done at full scale. So here's a list of our certified barriers. You can see our ETA number and our CE mark. So from 100 kilojoules all the way up to the 8,500 kilojoules is actually upgraded to 9,000 kilojoules. We also do have some low energy barriers, which I'm sure my colleague will go into a little bit more detail on that. So as you can see here, it goes up to a high impact of 9,000 kilojoules. So it can be classified into low energy, medium energy, and high energy. After 9,000 kilojoules, we don't actually have a barrier that can facilitate this type of impact. So we have something called an embankment. So anything over 9,000 all the way up to 50,000, we can consider an embankment, which is an MSC embankment, mechanically stabilized earth embankment. And this is basically a cross-section of it. So the penetration depth depends on the specific embankment features, such as size, shape, type of materials. There's no codified procedures per se. But Maccaferri have developed a simple way in the praxis for dimensioning terra mesh or green terra mesh with a university in Italy. Just to show you some considerations around the embankment, we considered a probabilistic approach to the energy levels. We have software that we're able to compute and do this probabilistic analysis, and we can provide the solution with drawings and site supervision. Here's an example of an embankment. So this is something that it's called a green terra mesh. It's reinforced soil structure with DT facing with a bio-jute, which is a type of material that allows vegetation to grow. And once that's greened, you're able to plant, and that can take very high loads, very high impacts. Then I'm going to move on to another product called Maccaferri. It's also relatively quite new. So you guys have seen steel grid HR, you guys have seen DT netting, you guys have seen HEA panels. So this is a combination of double twist wire mesh with rope panels in a bidirectional orientation. So Maccaferri has been developed to maximize the serviceability of the protected infrastructure. It has high performance along the longitudinal and transversal directions. The higher the stiffness of the product, the lower the risk of hampering running infrastructure after the rockfall event. So this is relatively new, is a unique product that has an outstanding tensile strength in the longitudinal and transversal direction. But one thing that's quite important is the punch resistance, and this is what makes this product so unique. So punch resistance, just from an explanation point of view, is the most relevant parameter to identify the behavior of the mesh on a slope. Even if defined in standard conditions with a specific load condition, it identifies the out-of-plane stiffness, which actually governs the deformation when the mesh is loaded on the site. So we've done the punch tests on this project according to the UNI standards, and MacArmor has proved to be 45% more efficient from a punch-resistant point of view than even steel grid HR. So it's one of our top products from a drapery perspective. Then I'm going to talk about Hello Mac, but this is just introduction to Hello Mac. My colleague, Mr. Fabien, will be speaking about Hello Mac in much more detail later. What is Hello Mac? It is a smart alert system developed to monitor our rockfall protection, and an alert is sent when rockfall events occur. So this product is in line also with our, as Mr. Nicholas said, with our AI and trying to become more smart and using technology. So this product is relatively new. The alert is guaranteed by a series of electronic sensors and immediately sends an alert to the custodian of the application. It uses modern technology, and in this way, it can be based in very remote areas with no coverage. And maintenance and replacing are very, very quick. So this is quite a unique product, and I'm happy for Mr. Fabien to share a little bit more about this product going forward and how it can be useful for the mining industry, for other civil application industries as well. So just to conclude, when rockfall events occur, they can cause massive damage to property, to life, to infrastructure, etc. So our aim from the Rockfall Business Unit is to preserve lives and infrastructure by reducing the impact associated with rockfall. And from a Maccaferri perspective, we have a very good rockfall team. I mean, we've been developing these products for a number of years now. We have a lot of support from Italy, from the South African branch as well. So we have a lot of technical information. We can provide a lot of technical guidelines and technical installations. We can provide drawings. We can do the designs. We have a number of case histories which are growing every year. The portfolio is growing every year. I think you guys will hear later from Christian on a project we did last year. We have the tools to facilitate this design, so I don't think you should be concerned. The rockfall design can be a little bit tricky. It also takes a little bit of experience to understand what you are modeling, which we have quite a number of experienced rockfall specialists in the Maccaferri group. So we can provide this full service, and we want to always be and provide innovative solutions which can separate us from other traditional solutions in the market. So I hope that helped cover just the basics to the introduction of Maccaferri products. And I hope that you guys learned something, and going forward, you'll hear more about these products, the applications, and some case histories. Thank you.
Thank you, Blaise. Incredible knowledge, incredible products, all of it to serve society, serve industries. Thank you very much for that. Just outside the auditorium, we have pop-up stands where the various technologies, products, and in some cases services are being showcased for Maccaferri. I'd encourage you to take the time to stop, speak to some of the experts, the expert knowledge that you can extract from the discussions. Please do so. The program you would have seen is scheduled with speakers, but on day 3, on Friday, we're going to be having breakaway sessions or room sessions where we would be focusing specifically on individual topics that will have, it will be discussions that you would have with people with common interest. It is at these pop-up stands that you will register for the Friday sessions. So number one, please visit the stands, talk about the products, get more insight and knowledge. And number two, please register for the Friday group sessions. Our next speaker is Mr. Leonardo Martino. Leonardo is a business developer and a structural and geotechnical engineer with a wealth of experience in environmental engineering since 2011. At the Indaba, his focus will be on standardizing procedures and the paramount importance of the CE mark in relation to the production and testing of rockfall products. His presentation will bring light to the critical role of standardized procedures and how they ensure the highest quality and safety standards in rockfall products. Please put your hands together for Mr. Martino, Leonardo Martino.
Thank you. Hi, everyone. My name is Leonardo Martino. I'm an engineer, civil engineer. As you probably understood from the introduction, I joined the company in 2012. I had several experiences around the world with Maccaferri, in Russia, Spain, Italy, and now I joined the company as a business developer for a rockfall business unit. My first time in South Africa, hope not the last. And today I'm going to give you a presentation that is named Manufacturing, Testing, Certification, and Quality Assurance of Rockfall Mitigation Products. Why? Because we have to understand the importance of quality in our products. We are engineers. We know how important it is to make a good design, to choose the right strategy to get the highest safety factor in our calculation. But we have to understand how important it is that the product that we use is the product that complies the characteristics, the mechanical characteristics and the durability we put inside the design. Because we cannot make a design with a certain product and then buy another one that just looks like the one we used inside the design. So we have to be sure that the product that we use in the end is a standardized product, and the product that we use in our design is standardized product, so that we will avoid any problem in terms of quality and in terms of durability of our structure. So this presentation actually is a sort of continuation of the presentation given by Blaise. We will have Blaise introduce you in a very general way the portfolio of our solution. We will see more in detail the importance of quality, and we will put the stress on the importance of quality. But before to get to the core of the presentation, I also have to introduce again rockfall barriers and drapery system in our portfolio, just to give you, let's say, the way to understand how we carry on the quality procedure, quality assessment for each our product. So let's start from rockfall barriers. As we just seen from the presentation from Blaise, the rockfall barriers are mainly made of 5 main components. Interception structures, so is this one. The laser doesn't work. So it's the screen where the falling rock impact, the support structures, the posts. We have posts with foundation, with, let's say, deep foundation, without foundation. The connection components, so all the different accessories and components which link the barrier to the foundation, so ropes, shakers, clamps. The energy dissipating devices, that actually are this one. The deformation of these devices gives the flexibility to the barrier and help the barrier to dissipate the energy coming from the falling, the falling blocks, and of course the foundation. We have 2 kinds of rockfall barriers. The barriers are categorized by the European authorities. We will see later the importance of CE mark and the way we have to work to get the CE mark, the final certification for the quality. So the barriers are classified in two categories: low energy barriers from 0 to 100 kilojoule, and high energy barriers from 100 to 9,000 or more kilojoule. Let's have a very brief introduction to drapery system. So we have two kinds of drapery system: open top for simple drapery system and closed toe for simple drapery system. The simple drapery system we already seen, they have just the task to, let's say, guide the shell of debris coming from the slope, guide inside a trench excavated there where we have enough space to excavate a trench, or in case we are very close to settlements or road, we can put some anchors and to let's say construct this closed toe structure to have the opportunity to create a sort of pocket to contain all the debris flow coming from the slope. The drapery system, we also have the secure drapery system with nails distributed on the rope. In this case, you can see the difference between the first slope that is not so cracked and the second one with the cracks, you know, deeper cracks. So we need to stabilize the slope. We need to put anchors and, of course, a netting system. We use this kind of solution when we have this kind of situation. We have a very unstable slope, but at the same time we can use this solution where we don't have the opportunity to excavate a trench or to create a pocket to contain the debris, because the road, the railway, or the buildings we have are very, very close to the slope. We will see later some example. So now we have a brief look to the portfolio. This is the first introduction to the second part of the presentation, where we will discuss about quality. So regarding barriers, as we said, we have two kinds of barriers. We have low energy barriers, as the international European standards classifies, from 35 kilojoule up to 70. And high energy level barriers from 100 to 9,000. The same thing about steel grid for drapery system and the mech armor. Where is? We have here the steel grid that actually is the, what is going on automatically? The steel grid that actually is the DT panel with woven, okay, with the steel cable. What is going on? Okay, steel cable woven inside the DT mesh. We have HA panels. What is going on? Is it fine? Okay, and we have HA panels and mech rings. As you can see here, there is a code at the top of every single material, and this is the code stabilized by the European authorities, which contains all the different components and the manufacturing procedure to standardize the material and to have at the end a material standardized with a certain characteristics that actually are the characteristics that we usually use in our design and are the characteristics that we declare on our technical data sheet in our software. We will see later how these documents are organized and why these documents are important to get the final CE mark. So the importance of quality. To get the final CE mark and to get the, let's say, a quality product, we have to comply with the most important international standard. European standard, international standard ISO, and this standards contains all the different characteristics that the material have to get the final certification, the CE mark. That actually, as we said, is the final proof of the quality of the material. So we have product standard and design standards that we use in our design activities. Before to get to the final CE mark, we have to understand how we classify our material, and we have to understand why the mechanical characteristics are important, and for this reason it's important to have a standardized material. Because we use, for instance, for drapery system, the main characteristics are the tensile resistance and the punching resistance that we use in our design to get the final safety factor. So you can understand how important, as I said at the beginning, how important it is to have this material standardized to get the final product completely in compliance with the product that we use in our software. The same thing for rockfall barriers. Rockfall barriers are usually characterized by residual height, maximum energy level, and service energy level. So when we use and when we decide to put the material inside our project, we have to take into account this kind of performance, but at the end we have to be sure that the performance we use in our project are the one we get when we put the material on site. So this is a slide which helps you to understand the main characteristics of a barrier, the residual height. In this slide is, I hope, clearly explained, is the height at the end of the impact, the HR there you can see. All the barrier from Maccaferri portfolio have the residual height bigger than 50%. So it means that after the impact, the residual height you can see here of the barrier is still bigger than 50% of the nominal height of the barrier. It means that you still have here a screen ready to protect from the debris flow, the debris coming from the first impact, and the barriers still work. So you can understand how important is this kind of feature and this kind of characteristics, because you have to consider that for this barrier already impacted, you have 50% of free space here. That this space doesn't give you any protection to further impact. And you can understand that an impact on a barrier is not, let's say, an event that happened only once. You have one block. No, you have a block and then some other blocks, some other debris coming from the first detachment. So this is why it's very important to have a certified material with a mark which assures the quality of the material, because it gives you the, let's say, certainty of the material, about the good application of the material, and about the fact that the material will work as we designed it during our design operation. Another important fact to take into account for barriers are the gaps which creates after the impact. You can see here, so the barrier has been impacted by a block, so you have some, let's say, free space at the left side and right side of the interception panel that doesn't give you any protection. So if you take a barrier that is certified with no lateral block, you can stay, let's say, relaxed that nothing will pass through the barrier even after the impact from the left side and the right side of the barrier. Another thing important for quality is the durability, because as we will see later, the CE mark and all the documents which lead us to get the CE mark also consider the durability as an important fact to get the final mark and to get the quality material. For instance, we declare for our DT mesh a durability over 120 years, and this is something that it's important to declare. So we can get this let's say, we can declare this only we are confident to have a certified material in our portfolio. The same thing about barriers. We have barriers with the Galmax C3. As we saw before from the presentation from Blaise, the coating that we usually use for barriers is a combination between zinc and aluminum. The Galmax C2 is 95% of zinc, 5% of aluminum. C3 is 90% of zinc, 10% of aluminum. That the quantity of aluminum is bigger This is why the durability, the working life of a barrier is bigger according to the different condition, environmental condition. So also we here declare for C2 environmental condition a durability of 120 years for Galmax C3. So you can understand how important it is to have a standardized material. So how can we get a CE mark? How can we get a quality material, a standardized material, and which kind of documents we have to follow to get this final result? So these are the documents that lead us to get the final CE mark: the EAD, the ETA, and the CE mark. And these are the procedure we have to follow to get the final result, so the CE marking. So we have the first part that actually is the part which is, let's say, more related to European authorities. The second part is related to our activities. So for every single material you want to market in Europe, you have to standardize the procedure of manufacturing of this material. The procedure of manufacturing of every single material you want to market in Europe are defined by the EAD. So inside the EAD of every single product, there are all the different, let's say, components and operations and activities, tests and other things like that you have to follow to get the final CE mark. Now we see which kind of, let's say, things and guidelines we have to follow to get the CE mark for our barriers and draperies. This is a more explanatory slide, which shows us how the procedure are organized to get the final CE mark for barriers. So we have these two EAD for rockfall barriers, low energy, less than 100 kilojoule. Another EAD for high energy level barriers, more than 100 kilojoule. Inside these documents are defined all the methodology to carry out the full-scale test, because the barriers are, big, let's say, complex, let's say, product. So you cannot test the barriers part by part. You have to test the entire barrier on site. So inside this EAD are present all the methodology for the full-scale crash test that we will see later, and defines also the control on the production and material. So we certify the material according to the EAD, but at the same time, after the approval, we call here ETA, we have to, let's say, hire a notified body that actually is an external company approved by the IOTA, the European Organization for Technical Assessment. And the task of this company is to check every once a year, once X months, that everything we, let's say, are producing in our factory are produced according to these guidelines, and only after this very, let's say, complex and difficult procedure we can get the CE mark. So you can understand how important and how complex and difficult it is to get the final CE mark and to get the quality material at the end of the story. The same thing for, for the drapery. The only fact is that the drapery can be tested on laboratory, so we do not have to run any full-scale test for this kind of product. But, the procedure we have to follow is the same actually the same for drapery. As I said, we have two different EDA. Now we'll see more in detail what's written in the EAD, that actually is the fundamental document which leads us to get the final CE mark. We will see what's written inside this kind of document. We have two different EAD, as I said, 100 and more than 100. Inside these documents are present mainly 5 parts. The first part is the components of the product. So you have all the components of the product inside this document. So when you produce the product, you have to comply with all these components. The lifespan and durability of the product, the methodology of full-scale test, the characteristics of the kit, and the production control we have to carry on during the manufacturing procedure. This is the full-scale test that we carry on every single barrier on our laboratory to get to achieve all the things written inside the EAD. Actually, the tests are organized in two parts. The first part is the maximum energy level, that's the one we just seen. And the maximum energy level test assesses the maximum energy level. The other two tests are service energy highest, let's say, energy level, but we can have also smaller impact, but we have to be, many impact like this, but we have to be sure that the barrier can withstand also to this impact. After this test, or during this test, we record all these different characteristics and output of the barriers. So we record through some gauges and through some sensor we put on the barrier, the impact speed of the block, the elongation of the barrier. This is very important. Probably you remember the slide that we've seen before about the nominal height of the barriers. The lateral gap, as we've seen before, so the distance after the impact between the screen and the vertical post, and all the forces acting on the anchors. So we also consider in this case all the forces applied during the impact on the anchors to calculate the anchors that actually we usually supply with the barrier. So inside these two very important documents, we have the procedure, the standardized procedure to understand and to assess the service energy level 1 and 2, the maximum energy level that actually is the energy level which classifies the barrier. So when we see okay, I have a barrier RB 3000. This 3000 is the 3000 kilojoule of the maximum energy level of the barrier. And here there is a screenshot from the EAD. I put this screenshot. I know that it's not good to put screenshot on presentation, but I just wanted to show you how the document looks like and how strict are the things written inside these two documents. So we have two different energy levels. The maximum energy level is passed if the barrier stops the block. And of course the barrier and the block doesn't touch the ground. The service energy level, as I said, is a different one. We use an energy level that is 1/3 of the maximum one already assessed during the first test. We carry on two different consecutive launches to assess the resistance of the barrier, because as I said, it happens that the barrier can be impacted not only by the biggest block, but several, let's say, smaller block, and we have to be sure that the barrier can withstand this impact too. So inside the document, as we already said, there are all the characteristics of the barriers and the way we assess these characteristics: energy absorption, action on foundation, residual height, maximum elongation, lateral gaps, durability, and other important things like this. And we classify, according to this material, the barrier in 3 categories. As we've seen, we're going back to the residual height. We classify the barriers usually, according to this document, in 3 categories: A, B, and C. The category A is the one with the maximum, let's say the highest residual height. So is the part of the barrier that actually, after the impact, still stay, let's say, ready to withstand other impact, smaller, of course. B and C. All the barriers in our portfolio, in Maccaferri portfolio, are characterized by category A with a residual height higher than 50. But let me say that actually the residual height of our barrier is not 51, 50.7, but we have residual height much bigger than 50. We have 70, 60, so the average is higher than 50. So we assess the lateral gap, the residual height, as we said, and this is a screenshot about the durability of barriers. So as you can see here, inside the document we've shown before, there are other link to other standard, let's say, standard documents which characterize the environmental level we consider and which gives us the estimated working life of the product according to the coating we use in our barrier. For instance, for C3, as I said, and a site environmental level of C2, so C3 it means 90% zinc, 10% aluminum, we can get up to 120 because the class, let's say the coating class we use in our material is always class A. And this is a slide which shows you the way we have to control the manufacturing operation during the production. So we have to control once a day, for instance, the mesh dimension, and of course also the control that the external body has to carry on to, let's say, certify the production to get the final C mark. And this is the final C mark that we get. So the document that you see here is let's say, a proof of the material as the highest quality. So is the proof of quality material. So when you have a product that is CE marked, you can stay safe, you can stay sure that the product that you buy is in compliance with the product that you use inside your design, and the product that, the product is in compliance with the things that we declare. This is very important when, for instance, when we go to a site and we see that actually material installed is completely different from the one that we put inside the specification, only because the material looks like the one put inside the specification. No, it's not the same thing. We have to take into account the fact that the material we specified and we supply the client with, went through this very big and very, let's say, elaborated procedure to get the final certification. The same thing is about the DT mesh. So we have 3 different EAD for DT mesh, steel grid, mech armor, HA panel, ring panels. The only difference between this kind of procedure, manufacturing procedure, and let's say quality assessment is that, of course, we can test the material inside the laboratory. We do not have to carry on any full-scale test because, okay, we can standardize, and of course this procedure is standardized. We can standardize the procedure to test the material. We can do it in a laboratory. These are some examples of the way, according to the EAD, we have to carry on the procedure for testing the material. So every batch of material is tested in this way. And this is important, as I said, for barriers, also for draperies, to get the final quality CE mark of drapery 2. So this is an example of a test we carry on in our laboratory on the drapery system. Again, we have here a screenshot from the EAD just to show you what's written inside the document. It's written that, the punching resistance has to be considered in a certain way. So everything is standardized. The same thing about the tensile resistance. So coming back to the slide I showed you before, when we consider the tensile resistance and the punching resistance, that actually are the main figure, the main characteristics of a drapery system, we have to take into account that the thing that we use is the thing that we get on site, is the thing that we get in our product. Because mainly we characterize the DT mesh or the other drapery system with tensile strength and punching resistance. Again, the durability, all the different cycles we have to carry on inside our laboratory to, let's say, prove and to certify the coating and the durability of the coating in a certain environment. And also from the EAD, all the different control that the notified body have to carry on in our factory to certify from the outside, let's say, that what we do is in compliance with the CE mark procedure. And this is the final CE mark for the DT mesh or for the steel grid or for the drapery solution in general. After the CE mark, we issued the declaration of performance of the material that is based on the CE mark. So we declare with our signature that the material is in compliance with the EAD, the CE mark, and other things like that. So this is a sort of final proof of the quality of our material. As you can see, you know, all these procedures are very, let's say, complex. So this is why it's very important, but it's very important to understand how difficult it is for a company which gives a quality material to organize all the things, and how much we invest to get this final result. So in conclusion, we started our journey from the international standard. The international standard, the EAD, that actually has the fundamental documents which lead us to the final CE mark, are based on this international standard. And having the CE mark, we have sure that the quality in terms of mechanical characteristics and the durability of our material are assured during the procedure of manufacturing and also during the development of the material. Now, just some slides to show you some, let's say, case histories of our rockfall barriers. Just to, let's say, close this presentation with some application of our material. We have here a rockfall barrier installed on a vertical slope in France, on a portal, tunnel portal here. So as you can see, barriers can be installed more or less everywhere. And some application of our DT mesh, or in general wall drapery. As you can see here, this is the pocket I tried to explain you before at the beginning of the presentation. As you can see here, the stress on the netting system is very high, and this is why we characterize the netting system with the punching resistance and the tensile resistance. Another application here of a drapery system with nails, done there where the pocket cannot be, let's say, developed by the system because it's very close to railway, and other application of drapery system for soil nailing. That's it. Thank you.
Thank you, Leonardo. Just watching that rockfall test that you do brings a lot of confidence. You know, we see these things on the roadsides, and you wonder how safe these things are. That's the first point I want to make. The second point, isn't that awesome that engineers get to do stuff like that? You know, mess around and break things and test things. And I mean, how many other careers you can do things like that? Our last speaker for the second session, Mr. Fabian Gazzardo. He's the head of the rockfall business at Maccaferri. He's got 2 decades of experience. Fabian spent 20 years at EPC Group, a leading French company specializing in explosives production, drilling, blasting operations, rockfall mitigation, and soil nailing. Fabien's commitment to industry advancement was exemplified by his role as a board member of the French Union of Companies, specializing in rope access work for geohazards mitigation. In 2019, Fabien brought his wealth of experience to the Maccaferri Group, based in Italy. He assumes the role of corporate business development manager for the rockfall mitigation sector, but there was more. Recognizing his exceptional capabilities in leadership, he ascended to the position of head of the rockfall business in 2024. Congratulations, 2024. Fabien will be talking to us on Make Your Rockfall Protection Smarter. Hello, Mac. Put your hands together, ladies and gentlemen, for Fabian Gazzardo.
Can you hear me? Yes? Okay. Thank you for your nice introduction. You missed one point, which is very important. It's, I'm French, and I'm a rugby expert. So you understand that I'm very happy to be here in this fantastic country who beat my favorite team some few months ago. And I hope that you will be so kind to let us win in the next World Cup. Okay? Okay, so joking apart, let's go to the point. Thanks to GAN to let me have the opportunity to participate to this conference. I want to mention that you are also a lucky country because you have a really skilled team of Maccaferri here on the Rockfall field, okay? Very experienced person. We are growing. We are increasing the size of the team to give you the best support that we can. And so we are very confident in our very nice future in your nice country, okay? I will try to... your colleagues give me one advice, is my French accent is not so easy to understand, so I will try to speak slowly, and I hope that my message will be understood by everyone, okay? So let's go. I need, here is the tool. Okay. So my colleague spoiled a little bit my surprise effect by indicating what is Elomac, but let's go deeply in the Elomac system. This is a table of content, okay? So what is the Elomac? Why do you need the Elomac? How does it work? How it is installed? What are the benefits? What else can we add as an early warning system? And some case stories, okay? So what is Elomac? So it's a disk-shaped alert system, okay, which can be installed on rockfall protection systems, okay, to send an alert in case of event to the customers or the authorities, okay? Here we have an example of an Elomac installed on a rockfall barrier when you have an impact. So the system sent to the users an alert, okay? There is a daily status of the system, so each day the system sent to you how the system is in terms of battery, in terms of status of work correctly with the connection, okay? So here you have a picture of the Elomac. It is open here, so I don't know if the laser, no, the laser is not working. But here, sorry for the people which cannot see. So here you have the Elomac which is open. You have 7 batteries inside the system, which gives you estimated lifespan of at least 5 years, okay? So it's not connected by wire, it's only working with batteries. And inside the Elomac, you have some springs, okay, here, which are connected to some legs. We call them legs, it's wire rope, okay? And when you have a displacement, you receive an alert, okay? So why do we need Elomac when we are doing a rockfall protection project? In Europe, we have been installing rockfall protection systems since decades, okay? We have kilometers and kilometers of rockfall barrier, catch fences, installed, and can be strange, but the customers, the authorities, don't even know where the barriers are installed, okay? Because they are in remote places, okay? In mountains, covered by vegetation after decades, okay? And so people changing in the organization, you go to visit the clients and say, I don't know what type of barrier, what type of energy, what is the status of my barrier, I don't know, okay? So Elomac is, has a geolocalization system inside, so you are able to have on a map the exact position of your barrier, okay? Second topic, which is important, is to know what is the status of your barrier, okay? Because you can have a barrier, know what it is, but what is the current status of my barrier? Is it operating? Has it been impacted? I don't know, okay? So with Elomac, you have the chance to know what is the status of your barrier. Another type of application is here on a drapery. So the same message is to have an alert when there is a rockfall movement inside your draperies. So HelloMac can be installed on different type of solution, okay? So it was firstly developed for rockfall barriers, okay? Now we start to implement this solution also in draperies, okay? By covering the mesh with several HelloMacs, and can be also installed on debris flow barriers, okay? Each type of solution where you have a displacement can be monitored by the HelloMac system. Also, one of the applications that we did some project on is to install HelloMac before installing the protection system itself, okay? In some channels, you can monitor some rocks, okay? And to understand if you have a lot of events, and also maybe to manage the closure of the road in case of event, but we will see this after. So how does it work? Here we have one quick video. If it works, okay. Okay, so as you have seen on the video, and I explained before, you need to pull one of the legs, okay, with a force approximately 25 kilos, okay, to activate the spring inside the HelloMac, okay? And when the spring is moving, you receive the alert, okay? Very easy. Here you can see you have one antenna, okay, which is communicating with the transceiver, the white box that we have seen before. Just I go back to this one. So you can have 100 HelloMac monitored by one transceiver. We call it UBIR, okay? And the distance between the transceiver, the UBIR, and the HelloMac is at maximum 5 kilometers, okay? So you can have your transceiver installed close to a building, somewhere you are confident, and then you can install the HelloMac wherever you want on your project, up to 100 HelloMac, okay? So you have seen, so we have one demonstration kit here on our booth, okay? So if you want to come, we can go more in detail. You can pull the leg to see the time of reaction, okay? It's immediately sent, it's a couple of minutes, okay, to your phone or to your email address, okay? It's a setup chosen by the customer. So here you see the network system. So you have all your HelloMac, okay, connected by radio frequencies to the transceiver, okay? The transceiver can be connected to the cloud, okay, by two ways. The first one is the standard SIM card, okay, so GSM if you have the phone coverage, okay. If you don't have any phone coverage, we have also the possibility to have the satellite connection, okay. So wherever you are, it works. You don't need any specific networking, okay. And then you have the UBIR, so the white box, sending the information to the data server to manage the alert system, okay? One other nice feature of the system is that you can add local alert. Okay, so if you have an impact with the hub here, we can manage to have automatic closure of the road, or to send some sirens, okay, or lights to inform the workers, the population, everyone who can be impacted by rockfalls. So as I mentioned before, here you have the type of connection that are available in our system, so via satellite or via phone networks. And we have developed a specific application that you can download freely on your phone, also on the computer, where you have the geolocalization of your project, okay? Position of each LOMAC, position of the hub here. You receive the alarm, and you can monitor everything from your phone. It's very easy, okay? So here are the systems that we can add, as I mentioned before: light, sirens, closure of the road, okay? So how do we install LOMAC? Here you have one picture of one LOMAC here, installed on the post pillar of a catch fence, okay? It's very easy to install. You don't need to be specialized in computing, in wiring, to be electrician. You just need to install a counterplate, some bolts, some nuts, and it's automatically working, okay? You don't need to do any setup. The setup is done before you receive the LOMAC on the job site, okay? So you just install your LOMAC like this. You have the antenna, and it will communicate automatically to the transceiver, okay? Here you see the legs, the 8 legs coming out from the LOMAC, and these legs are connected to small wires going along the net of the barrier. So here you see one LOMAC, the 8 legs, okay? So you have 8 points of control for 2 spans of your barrier, okay? And when you have an impact, the cables are moving, pulling the leg and triggering the system, and you receive the alert. So the advantage of the LOMAC, it can also be retrofitting some barriers. So if you already have some barriers, we are able to install LOMAC also on existing project. With the length on Maccaferri barrier, because we know perfectly the deformation of our barrier, we are able also to set up a level of energy for which you want to receive an alarm, okay? So for example, if you want to receive an alarm at the service energy level, you can set up these legs with a different lengths compared if you want to receive an alarm at the maximum energy level, because this energy level will have a bigger deformation, okay? Here you see one LOMAC installed on one barrier. Here it's a project done in Italy. It's a very touristic place, okay? The client wanted to have full information of this big unstable block which is installed here, okay? So we developed this type of system. So this is the block, you see. The LOMAC was installed on the unstable face of the block, and the legs here in red are connected outside of the surface, unstable surface. So in case of movement, okay, you receive a message, say, oh, be careful, it starts to move, okay? Here is another type of application, just a drapery system installed on top of houses. So here you have the hub here. You can see that the hub here is equipped with a solar panel, okay? So working also with battery. And here, in the red circle, you have the LOMAC. Okay? Here you can see how the LOMAC is fixed on the slope. So the counterplate is equipped with a central hole. You can put an anchor and fix the system to an anchor. Okay? So it's very easy. Other type of application, here we are in case of a channel, active channel for debris flow in Italy, okay? So the HelloMac is connected to the rocks, to the boulders, okay? When you start to have a flow, so there is no rockfall protection here. When there is a big flow, the rocks start to move, pull the legs, and there is a system of lights here at the bottom, on the right side, which are at the road level, and when it lights, so the people know that they have to stop because there is an event. Here to show you how easy it is to install, it's a type of same system in a channel, and the HelloMac is fixed on the tree, okay? So just to show you the system, again, debris flow, moving the ball, and closing the road. Okay, so here we are talking about the environment where HelloMac can be installed. It was designed to resist to very aggressive climates, so snow, rain, sun. It can work from a range of temperature from -20 to +40 degrees, okay? So the benefits, a little bit a recap. I see that my presentation is going very fast now. So it's a real-time alert system, and the HelloMac send to you every day what is its status, if the level of the battery is okay, if there is problem of connection or not. So if there is any problem, you will receive an alert, okay? If there is no problem, you don't receive any message. But every day, every 24 hours, there is an auto checking of the system to check that everything is working in case of alarm. No problem of network coverage, so two options, GSM or satellite. One HelloMac is able to measure 8 points of control. So, for example, on draperies, you can monitor easily 8 points of the draperies. It's very easy to install. So the weight of the HelloMac is 8 kilo, so it's not very heavy. You can just fix it on your protection system, and you don't need specific skills to do it. And it's suitable for any type of rockfall protection, and also to retrofit all the protection already installed, even on competitors of Maccaferri rockfall barriers. Maintenance free, so you have 7 batteries inside the HelloMac, which with a lifespan of 5 years. The batteries are standard ones, you can buy everywhere. It's a few euros each battery, so it's not a huge cost to make the maintenance, okay? You don't have any wiring activities, which is very important also because you have also some existing system with wires going everywhere. In case of rockfall, you can have the risk to have some damages on the wiring, okay? Here with HelloMac, there is no problem of this type. The HelloMac also was tested against an impact, okay? So it's able to resist to a 100G impact. It's very resistant. It's made of an alloy of aluminum and another material, I don't remember the name, but it's very, very resistant. Designed to work on every aggressive environment, and tested against impacted, I already said this. So this was the first concept of HelloMac. It was developed to be installed on rockfall barriers. Starting from this point, we understood that maybe we can also expand a little bit what the possibility of this system, okay? So this is the same presentation I did before, but instead of having HelloMac, we can replace the HelloMac by other sensors, okay? Other sensors having the same coverage. We're talking about 5 to 8 kilometers from the hub here, and to receive also alarms with other type of sensors and detecting system. First one are strain gauges, okay? to measure displacement. So same system, we are able to put some strain gauges with a radio interface which communicate with the transceiver. Okay, so the same, you don't need any wiring system. Inclinometers. Okay, so the concept is this one. You can substitute the LOMAC by different type of sensors. Okay, so inclinometers is one project done in Italy. Okay, everything with solar panel, and you have the radio frequency transceiver. Okay, piezometric level sensor also. Range gauges, okay, and water level monitoring. So if you want to receive an alarm because the water level is increasing and you have a risk of a flood, okay, so this is something also which was already done. Here you have the installation of the system, okay, with the sensor monitoring the level of the water, okay. Here you see on the app you are able to geolocalize the position of the sensor. We can monitor wind, speed of the wind, wind direction. Here is one example with the wind sensor on the top. And to finish my presentation, some case stories. So this one, we already saw it, okay? It's done in Italy. So now we started the business first in Italy because it's, you understood, it's probably one of the biggest market around the world in terms of rockfall protection, okay? Maybe just same level that Japan and China, okay? But Italy is a very, very big market, okay? Very mature market. So we have a lot of projects done. Here you have project with, see the green dot are the LOMAC, the purple one is the UBIR, okay? You see again the LOMAC installed on the post. Another type of project. Again, this is in south of Italy. I want to go quicker on this type of barrier. So here it's a project also in Italy. So this one, okay, here it's an interesting one. It's an ongoing project, so made for draperies. Okay, so we are developing. So this is the current state of the slope. The authority wanted to monitor very carefully the system. So here you have for each system is one LOMAC, okay, and we are covering with 8 legs all the full surface of the draperies, okay, and we have a system to monitor some traffic lights on the road. Here it's a project in India, okay, so this is a unstable slope, okay, so we worked with the authorities. So here we have a different sort of sensors. We have extensometers. We have some LOMAC also to measure the displacement. We have some range gauges, okay? So also it's an ongoing project. I was quite fast, despite the advices of my colleagues not to speak too fast. I hope it was understandable. If you have any question, we have the demo kit at the booth, okay? We'll be very pleased to answer to all of your questions. And I think now it's time for lunch. So thank you very much for your attention, and hope to see you at the booth.
Thank you very much. Thank you very much, Fabien. Don't leave, because of the flexibility that we have with time.
Yeah.
I think we could make use of that 15 minutes that we have.
Yes.
At least 15 minutes to field a few questions. But before I do that, I have to say this. I see the French are still trying to make a point. So somebody got it there. Hey.
I didn't. Huh? 1 point you're talking about. I will not go to New Zealand for holidays, you know.
But trust me, we suffered in that game. You know, it was such an incredible game. And I'm delighted to be on stage with you, Fabienne, as a South African and as a
Thank you for your support.
French national.
Appreciated.
You know, it feels like when we were at varsity and we were studying, you know, when you used to get your results, you're at varsity, so you care for your mate, but when they fail and you pass, you're cool. When they pass and you fail, you're not cool, you know, so it's that kind of relationship. So you just don't know when to celebrate your colleague's victory. I love the research development, the product. Have you used this in South Africa?
Currently not. We have one demo kit here to start the promotion, okay, in South Africa. But I'm sure that with our strong involvement of the local team, we will start a very few projects very soon. Yes.
Okay. There's plenty of opportunities, not only in the mining sector, or I mean, there's plenty of opportunities even in the municipalities with clients like Sandrel. While we're having this conversation, please pick your hand up. Hopefully I can see you with all the lights. I think there's a question here. Is that right? Okay. Won't you just stand up, introduce yourself? Do we have a roaming mic, please? I'm happy to use this one, or do you have one? There's a gentleman here. Won't you stand up, introduce yourself and your question?
Hello, everyone. My name is Davis. I'm from Vedanta. It's a mining company in the Northern Cape. Just a basic question for the mining application. Can you increase the sensitivity of this LOMAC? Because I saw it's 25 kilograms.
So it's your sensitivity about the 25 kilo? So no, because let's say the 25 kilos are set up to avoid false alert. Okay, so the setup of the system is based on the length of the wire cable, which is fixed on the point that you want to monitor. Okay, so because the system works on displacement. Okay, so you have to install the wire cable very tightly, okay, in order to receive an alert as soon as there is a small displacement. But we are not talking about a judge, okay? So the accuracy of the system is not in millimeters, okay? We are talking about several centimeters, okay? So it's an application mainly for rockfall. I mean, if you want to monitor a very small displacement of several millimeters, LOMAC is not due for this, okay? But the 25 kilometers are just to avoid to receive a false alarm because sometimes you have some barriers, you can have some animals working on the net. So to avoid to have some false alarm, this is a setup which was done on this purpose. I hope I answered clearly to your question.
I see the hand there, the red shirt. Fabienne, the HelloMac, does it? It's a wonderful early detection mechanism. But do you offer the full service? The product is one thing, but the response times, the logistics behind it.
Absolutely yes, because this concept was developed by a partner. Okay, the name is NESA, which is a company specializes in this type of solution, and we bought the company. Okay, so now this is our knowledge. Okay, so we are it's a Maccaferri system. Okay, so we are managing the cloud systems, the alert system, everything. Okay.
Okay, so it's not only the product; it's the full range of service response times and so
absolutely.
on.
The setting is very easy. I mean, you give to us your phone number, your email address, okay, and after this, as Maccaferri team will set up everything for you in terms of communication and so on. Okay.
Okay. Sir, yes.
Hello, my name is Kurt Pieters. I'm from CAT Mining Supplies. We do installations of various products as well as the mesh and barriers and stuff. My question is about HelloMac. You said that when there's an alert, it goes to Maccaferri, or does it go to the customer?
So it can be the two options. The standard one is it goes to the cloud, okay, managed by Maccaferri, okay, and then it goes to the customers through the email or the phone, okay. We have some mining company which don't want, let's say, to share the data or want to be the only manager of the system. And in this case, we can also integrate the LOMAC system into the mining monitoring system. Okay? It's a request we already had from a big mine in Peru. Okay? And so we didn't finalize yet the order, but we are working on it. And this is something we are able to do from a technical point of view, yes.
Okay. Any other questions from the audience? Yes, sir.
Hi, my name is Sean from the University of Johannesburg. I'm a student. Okay,
University of?
University of Johannesburg.
UJ, okay.
Yeah. Okay, so my question is the Hello Mac. I saw that you use it in on the side of mountains and other areas like that, which is mostly vertical. So I wanted to know with the kind of like rock barriers that you had, the ones that were horizontal, you know, the demonstration that you had where rocks would fall into that thing that looked like a net, that barrier that kind of looked like a net. Yeah, so I wanted to know if it's also integrated into such a system, into that type of system.
So you are talking about the barriers which were installed horizontally?
Yes.
Yes?
Yeah.
On the previous
On the
presentation?
embankments,
Yes.
Absolutely, yes. The same, because you install the LOMAC. When the net starts to deform itself under the impact, it will pull the legs of the system, and you will receive an alert. So vertical, horizontal, no issues.
Okay, so in such a case, how would it be installed?
By climbers on the post. So
I
the
mean-
people that are doing the installation of the barriers are the same people. So you are connecting the LOMAC with a counterplate on the post being horizontal. Okay? You have a counterplate, the LOMAC is the same. You just need to install the LOMAC on the downhill position to avoid to have it impacted by the rockfall. But it's exactly the same type of installation than doing it on a standard semi-vertical barrier.
Okay, thank you.
Thank you.
So I just want to understand the research and development phase of this thing. Have you partnered with any South African institutions or universities?
So we have partnered with one Italian university in order to validate the length of the cables to be installed on each type of barriers. Because as you have seen on the test, depending on the barrier and the energy for which the barrier is designed, the net deforms on a different way. Okay? So for each product of Maccaferri portfolio, for each barrier, you have a different setup of the length of the 8 wire cables on the net. And this was, let's say, a simulation done in accordance with the university in Italy.
Okay.
Okay?
All right. Young man?
Greetings, everyone. My name is Q. I'm from the University of the Witwatersrand. My question, okay, firstly, great presentation on all the products.
Thank you.
And then my question was, I saw the products were mainly focused on rockfall control, which for me was, do you not feel like that's limiting the products or the company when there's an entirely different market out there, outside of just rockfall control? You can, for instance, with the HelloMac, you can look at climate control. You can look at natural disaster control, since it's an alert system, right? And not just that, but the other products as well. I could pick up a lot from them, which I felt like when we just use them on rockfall control, you are limiting the products, whereas there's so much potential for the products. I'm not sure if the company is actually looking into venturing into other disciplines or other ways in which they can adopt the product into. Yeah.
Okay, we need to hire this guy to develop the business, no? There is a vision here.
That's a very strategic question, yeah? And he's a bitsy, eh?
So if I understood clearly your question is why to have some restriction about the rockfall monitoring system, correct? This is the point?
The point was limiting it to rockfall control only when there's so much potential for the
So
project.
we are, as I said before, we are closing the fact to buy the company, our partner, for which we work for 4 years now to develop the system and so on. So now it's part of Maccaferri Group. And we are developing this type of alert system to all our range of products. Okay? So Terra mesh system, embankment, walls. So we have a vision also to implement this type of not only the disk itself, but other type of sensor, okay? But which is important in this type of solution is the easy installation part, the very quick answering, the no wiring, everything by IoT. So we are thinking about doing, we are working on it right now, for sure.
I see a hand there. Okay. There's a hand here.
My name is Ben. I'm also from...
Could you speak a little louder?
Yeah, please.
Because the speakers are out that way and we can barely hear you.
Okay, fine. My name is Ben. I'm from the University of Johannesburg. I'm a civil engineering student. So I wanted to ask if Hello Mac was made specifically for Maccaferri, or you work with other companies, and is there anyone else who's doing the same thing in the industry, or yeah?
Do you have essentially competing products?
Yes, we have. Unfortunately, we are not alone on this market, yeah, because the monitoring systems are, developed since years and years in a lot of fields. I mean, we are not inventing the monitoring system. So here it's an alert system. So the difference is that you receive a message only when there is an event. It's not monitoring as you don't receive, I don't know, the measure of the displacement every minute or in continue, okay? So yes, there are some other system on the market. I will not do the promotion of the competition, but yes, of course, there are other systems. But I would say the specificity of our system because for products, for system to be installed on rockfall protection, there are very few, okay? Maybe 2-3 systems are already existing, but our system is really the best, not because it's Maccaferri product, it's because in terms of network coverage, okay? Satellite and GSM, I think we are the only one doing this, okay? And the fact that the system can be installed on all our products, okay? So barriers, mesh, debris flow, and I don't have in mind other system so easy to install, to be able to be installed on such a diversity of products. So this is the uniqueness also of our system.
Okay, let's take one more. One more question. Fabian, while we're waiting for that question,
I can tell you because usually there is one question I never answer.
Which is?
What is the cost? But this question was not raised. So if you have questions about the pricing, you need to refer to the local subsidiaries, okay? To your Maccaferri local people here, okay?
So, well, my question is related to that. There are channels and partners here, and there's other end users, consultants, and so on. How do we contact you, or how do we relate to you in relation to this product?
Local Maccaferri subsidiaries,
Maccaferri office
yes.
here through Gans team.
To Wynind and his team, to Blaze, everyone in the market, you can ask and they will give you a quotation for this type of products. The price depends, of course, on the number of Elomax you need to install, because on one fence you need several Elomax, okay? Depends on your project, so we will customize the offer according to the project.
Okay.
Okay.
Thank you very much, guys. Won't we give a hand to
Thank
Fabian?
you. Thank you.
Okay. All right. One thing, I've been punting civil engineering since I got onto stage. One thing was quite interesting in the way the questions were asked. Those who were civil engineering students or civil engineers said, I'm a civil engineering student. I had the good fortune of meeting with Eric Hall. Does anybody know the name Eric Hall? Some of the senior engineers here might know the name Eric Hall. Eric Hall used to be the city engineer for Johannesburg in the 1970s and 1980s. And when I met with him, I mean, he was quite senior. He was probably pushing on 90. And proud civil engineer. And, he had that wisdom of age and experience. And it was wonderful to talk to him. His faculties were good and still bright as ever. Featured in so many different magazines locally and internationally. And I was intrigued, so I positioned myself in the interview, in a discussion with him, as though I'm being mentored by him in this conversation. So I asked him, Mr. Hall, you've had such an illustrious career. Have you ever thought about what you would have been if you were not a civil engineer? Oh, that's easy, Manglin. That's so easy. I would have been ashamed of myself. Ladies and gentlemen, we're going to have lunch, and I'll see you here in an hour's time.
doing, your living organism and all its behavior, it's expressing it as a singer sings a song. Okay, all flight controllers, gonna go for landing.
Okay, good afternoon, everyone. Please take your seats. Let's get started for the last session of the day. Just a gentle reminder to visit the stands outside. Take advantage of asking questions to our colleagues who have the technical stands and products, the knowledge that they share with you, and then at the same time to also register for the Friday sessions if indeed you'll be joining us on Friday. Please take advantage of that. Our first speaker for this afternoon, I just got to meet her now, and she's an incredible person. I had a conversation with my 5-year-old some time ago, and he was saying to me that he wants to be a vegetarian. So, I mean, we're a family that eats meat and enjoy our meat, and this dairy products, there's no complaints whatsoever. So we were concerned, where does this vegetarian business come from? So my wife started probing and said, what do you mean you want to be a vegetarian? And he says, I feel very sorry for animals, and I like taking care of animals, and that's why when I grow up, I want to be a vegetarian. Dr. Antje Higo has a fascinating background in that she started her career as a veterinarian, as a vegetarian. Now, that's a bit of juicy information I do not let go on stage. So she's blushing. I can see the red from here. Dr. Antje Higo, doctor in philosophy, she's a director at Titan Geotechnical System in South Africa. She's based in Johannesburg and is currently a director, as I mentioned. And she brings experience from previous roles at Vimico, and she also lectured at UNISA. Antje holds a 1991 Doctor of Philosophy at Ludwig Maximilians University in Munich. With a robust skill set that includes business strategy, project management, research, business development, change management, and more, Antje contributes valuable insights to the industry. That's quite impressive, Antje. Please come join us on stage. Put your hands together for Dr. Antje Higo. You're talking to us about rock anchors.
Thank you. I knew you would have abused it. I would have kept quiet. Good afternoon, everyone. I hope you had a good lunch. I must say the food is fantastic here. Thank you very much to Maccaferri for that. As you heard, I'm from Titan Geotechnical, but I'm actually wearing 2 hats today. So Titan Geotechnical supplies geotechnical system to the industry for the mining and the geotechnical industry. But at the same time, I'm standing here for a company called Vimico. And that is where my rock anchor theme comes in. Vimico is a mining contracting company, 35 years old, has massive experience in rock consolidation and water sealing inter alia with resin grouting and rock anchoring. Just want to give you a short overview of what I will be talking about. So I will give you a short introduction about us, about anchor systems in general, and then I will concentrate on SDAs or self-drilling anchors or hollow bars. So I will just introduce you to the systems. We'll give you some application examples in the mining and civil industry. I will briefly talk about the current legislation in South Africa. And then the second part I found very important, and that directly speaks to Leonardo's and Blaze's presentation. I will talk about quality requirements. So what do you look at, especially as an engineer? What do you need to look at? What does an SDA need to give you in order to fit your project? Okay, as I said to you, Wimico, the mining contractor, started in 1988, and since then we have been in the gold, platinum, coal mines, open cast, underground, installing a lot of anchors, resin grouting, and cement grouting. What is an anchor system? What does an anchor system does in general? Per definition, it just gives you a transfer of tensile or compression loads into surrounding stratum. That means it just compiles the strata to give you the strength that you want from the anchor. You get different systems. They are different according to their design. The two major differences is you either have strand anchors. You have seen them outside maybe at the booth from Maccaferri. They have various strands inside that are tensioned after installation. And you have bar anchors. Bar anchors can either be hollow, like your SDA, or a solid bar. They're usually fully threaded, or partially threaded, which is a fairly new system on the market. It gives you a better elasticity and ductility. Then your period of application and your design life makes a difference. So you will look at temporary design, less than 2 years, or permanent design, but also the constraint that you have with your project. How do you know if that bar that you want to use or the anchor is for permanent or temporary? The manufacturer or supplier should be able to give you the approval with all the details, and you should then request that. Another interesting or very distinctive differentiation is you either have a 3 separate step in installation. So that means you drill the hole, you put the casing in if needed, you put the bar in, and then you grout. With your hollow bars, it's actually 3 in 1. So while you drill, you already grout, stabilize your borehole with that, and your final grout will be then before you disconnect your drill rig. There is according to legislation and standards, there's differences according to size. So sometimes we talk about a ground anchor, which is a diameter more than 300 mil. A micropile is less than 300 mil, or we have soil nails. Your Eurocode, I mean, as an engineer, you know them all. Your Eurocode, your standards give you more information about the requirements for your bar. Just a short summary. So your ground anchor, you have a European standard 1537. There you can use strands, hollow or solid bars, while for your micropiles and your soil nails, you only use hollow or solid bars, no strand anchors. So here's an example for strand anchor, solid bars, SDA. So that's my main topic. Hollow bar is a form of a rock bolt with a hollow core, which makes it unique. As I said, it fulfills 3 functions in one. It can be used with cement grouting when you flush with a more watery cement solution and then grout later, or you use it with resin, hard or fast-setting resin, where you drill with water or air just to cool down your drilling process. You can, usually your full length is grouted, but you can create a free length if you need that. The set, you can use them in tension, in compression, and specifically for incompetent ground conditions. How does a system look? So you have a head construction, you have your center bar, which can be extended, usually 3 meter long. You can use a coupler and a centralizer to extend and make sure that your bar is in the center of your grout body. Then you have a sacrificial drill bit, which you use or choose according to the application. Different applications for foundations, underpinning, tieback walls, excavation, soil nailings, anti-heaving. I will now mainly look at soil nailings. In the mining industry, we have high walls, we have tunnel face anchors, we have compilation of your side walls and of your hanging walls. Few examples in South Africa, so that is PPM mine, where we installed 4016s and resin grouting. You can see it's very fractured rock. So what was done here is on the bench we installed packers, injected hard fast-setting resin, consolidated the whole wall. You can see the resin penetration there. And after that, we installed 4016 anchors with resin grout. That is what the anchors looked before grouting in the second phase. Then I said to you, we work underground. So underground, we use anchors with fast-setting resin for rock consolidation, especially in deep level mining, like in your Sibanye operations. That is actually a site on a Sibanye operation after a seismic event, which occurs regularly there. So you can see your props are damaged, your normal bars failed completely, while the areas where a hollow bar was used with grouting and netting, you can see damage, but it's still standing. Other applications is on slope with nettings. We've seen that this morning. So I will not talk much about it. Geomesh use. So what legislation is available or is currently in place in South Africa? Until recently, and I'm talking about 3-4 years ago, there was not really any legislation that was applicable or compulsory, but the industry, various industries actually felt the need to standardize. So what happened? The European standard for micropiles was adopted as an SABS standard. Part of that standard, there's normative references to the material requirements of a hollow bar. So these are EN 10210 and EN 10219. These are the only two standards that really refer to hollow sections. Other steel does not comply because a hollow section gives you a special characteristics. Then, to a certain extent, SAS 920 for reinforcement steel is relevant because if you look at the thread, you want to have the same thread geometry on your hollow bar that you have on your reinforcement steel. For the mining industry, there's only two standards, and these refer to capsules, resin capsules and bolts, so they're not really applicable to your hollow bar. Then there's a couple of international standards that you might come across that are used by various suppliers. For instance, you have a European standard 183. This refers to steel for quenching and tempering. Quenching and tempering makes the steel extremely hard. Hard steel is good, but it becomes very brittle. So if you want to use it for a soil nail with your installation, percussion installation, the steel is not suitable. It's also not part of your standards for hollow sections. Then you might see an ISO standard 1720 or 10208. That's not a standard for bars or anchors, that's a standard for drilling equipment. So that describes basically the geometry of your drill steel. Sometimes you will see EN 10025 that suppliers will use. That is a steel that is only applicable, or that standard only applicable for steel for flat products. So it specifically excludes hollow sections. So now we're looking at the quality. I have heard a few times that people told me, what do you need of any quality? A bar is a bar, and once it's in the ground, you don't see it, it will do what it's supposed to do. It's not that easy. Firstly, if you think of the effects that an SDA has or undergoes during the installation process, also depending on your soil, you have compression forces, you have bending moments, you have torque, and you have a percussion impact energy, which, especially if you think you're working in rock, which is quite tremendous and quite hard. After installation, you have water, you might have very corrosive soil, and as we saw this morning, you might have sudden impact, rockfall, seismic events, which causes stress and overload on your load-bearing element, on your steel bar. Therefore, your material must be extremely adequate to withstand all those forces during and after installation. If you compromise that, you will end up with a failure, and that will affect at the end of the day, your safety. The requirements, very important, is not just for your steel element, but for the whole system. The European standard and the South African standard specifically say your weakest link must comply. So what are we looking at? And I think, Leonardo, that is a bit of a duplication of what we heard from you with your mesh this morning. So we look at steel. We looked at steel characteristics. We look at thread geometry. That must all work together to give you the correct product for your application. So firstly, if you look at steel, we use fine-grained steel, structural steel versus normal structural steel. The best value for that is your carbon equivalent value. That is calculated out of the composition of an alloy steel, and each steel that complies with these norms can only have a certain maximum CV. If the CV is higher, that steel is not suitable to be used as an anchor or a hollow bar. What does it mean? Your fine-grained steel is tough, it is more ductile, and it has a high notched impact strength. That means if you have a percussion or hammering on your steel, it doesn't result in microcracks, as a more brittle steel would give you. A fine-grained structural steel is not sensitive to stress, corrosion, cracking, so your corrosion protection is already better. And as I said, the steel composition, as per the relevant grade, is listed in those European standards, gives you the CV. What is the impact strength? How is it measured? You might see that's what you want to see on your mill certificate of a steel and of your product. They talk about a Charpy factor. Charpy factor is measured in joule at minus 20 degrees. And then depending on the steel quality, you have different factors. So the higher the factor, the more ductile, the more resistant your steel is, the less you have microcracks during installation or impact. Just to give you a few values, your normal structural steel, you look at 27 joule, your pre-stressed steel is 15 joule, your reinforcement steel is 100 joule, your S460 and 8, which is your reinforcement bar steel, can go up to 80 to 100. The minimum value that is required is 40 joule. And that means that steel can absorb 40 joule of blow energy without being damaged. Then you are familiar with yield stress and yield strength. So your yield strength is important because it represents the stress beyond which a material deformation is plastic. That means, for instance, your bar stretches under load. For SDAs that you use with cement, it's important that your yield strength of the metal, of the steel, is equivalent to the yield strength of the concrete. If it's longer, that will result in cracks in your grout body, which result in corrosion. So you don't want to go higher than 600 MPa. Your yield stress, it's basically the limit beyond which the material will be permanently deformed. So if you have a steel that is ductile enough, under sudden load it can deform, but it can actually go back in this original form and length. Once you pass the yield stress or the proof stress, that deformation is irreversible. And that means, strictly speaking, your structure failed, so you should actually do something. This is just a graph to show you the different yield stresses of various anchors in the market. So on the left side, you see the 0.2% part. That is where actually your steel can deform, where it's still reversible. At the side, at the bottom, you see the ductility and the reserves for overloading. According to the standards and regulations, each steel your steel that is compliant must have at least between 2.5% and 7.5% ductility. It's very important that you see if that has been measured of the raw material or after your bar has been rolled, because when you roll a thread onto a bar, you change the characteristics and your elasticity also changes. But you see, for instance, the green line is what you want to see. That is, for instance, your GV bars like that, your rebar, the Titan micropile, or your Titan hollow bar is that. So you see it goes up to 6% strain. The higher your stress goes, the harder your steel becomes. You see, the shorter your elongation becomes. And the shorter the elongation it becomes, the more sudden you will see a failure, because then you don't have that stretching period between overload and final failure. The ductility I mentioned is the elongation of the steel at the ultimate load. Depends also on the thickness, so that's why you have grade A, B, and C with different percentages. And then your UTS, your ultimate load, that is where you do the tensile test until you have a rupture. Just to give you a few ideas, the ductility test you do by bending and rebending your steel over a mandrel. That's a very common test for your rebar steel. So because your SDA fulfilled the same function than your rebar, you ideally want the same characteristics. So you see here, in the center you see a normal rebar steel. On the right side you see a Titan bar 4016 with a T-thread. On the left side you see a R-thread R38, which did not make it. So that's just some microscopic examples, because you won't really see. If you install a bar with percussion, you won't really see if there's micro cracks or not. So what happened if you actually take one of these bars and cut it, you will see those micro cracks. And if you have micro cracks like that, you can just imagine that bar will not be able to carry the full load that you think it can carry. Then the second part is the thread geometry. So on the market, you have two different threads. One is called a rope thread or an R thread. The other one is called a trapezoid thread or a T thread. A rope thread complies with the rock drilling equipment ISO standard. That means it's very shallow. It has a 17-degree angle. That means it doesn't give you a good shear bond, while a T-bar is equivalent to your reinforcement bar. You have a 45-degree angle, and your shear bond is much better. You want a good shear bond because with a shear bond, you describe the stress that a force applies parallel to the surface of the bar. So the better your shear bond, the more your bar can actually hold, especially when you look at tension. Another thing with a thread is not just your shear bond, but also it's considered as a corrosion protective measure. Sometimes you would prescribe for a project you want a single corrosion protection or double corrosion protection. Usually a single corrosion protection, people think it must be galvanized or zinc diffused, which is not always the case. It depends on your bar. For an R bar, with very shallow angle, yes, you need that as your first protection. For a T-bar, like for your reinforcement bar, you don't need it under normal soil conditions. Only if you have very corrosive conditions, then we recommend that. The reason for the difference, you can see here. If you have a T-bar, I don't know if everyone can see. If you have a T-thread like here, you have a lot of very small cracks. Those cracks don't penetrate your grout body, and they're usually smaller than 0.1 millimeter in thickness. While on an R bar, you see it's much more shallow, so your cracks are wider, and they go through your whole grout body. And that is why with that type of R, you need to have a primary corrosion protection form of zinc diffusion or zinc coating. Where do we get the 0.1 millimeter from? That's actually written in the European norm for soil nails, 14490, where it says if a bar causes cracks in the grout body less than 0.1 millimeter, this crack is considered a self-healing and doesn't need any further corrosion protection. Just for testing, bars were grouted and put under load and then checked. The grout body was checked, so in that case, it's a Titan 5226 with a T-thread. And the cracks were measured and the amount of cracks was measured. So under the characteristic load carrying capacity of that bar, under 650 kilonewton, you can see the majority of cracks, 100% was below 0.1. So that means that bar doesn't need to be galvanized because your grout body acts as a full corrosion protection. I said earlier, we talk about the weakest link. Your weakest link is your coupler. So you want the coupler to actually withhold the full load and the overload. For that, you must make sure that you have a good interlock, that you have a central stop, that you have O-rings to seal. Then you can also use a much higher pressure when you grout. If you don't have that, if you have a normal coupler with a lot of play, what happens during installation, some of the blow energy doesn't transfer to the next bar, but into the coupler. The coupler heats up because of the energy, and you have a failure of the ribs, of the thread inside the coupler, and your bar fails inside the coupler. This is just a few technical data sheets. That's a very comprehensive one, gives you your strain stiffness, your bending stiffness, everything, your characteristic loads. Then when you search for bars on the internet, you find things like that, something like that, where it gives you the thread type, the ISO standard that I talked about earlier. There you even see the steel type. Usually you get that with a mill certificate. These steel types are not compliant with the current legislation. How do we do the tests? We also have, like for the Titan bars produced in Germany, they undergo the same testing system for approvals like the Maccaferri mesh, like we learned this morning. But we sometimes do tests in South Africa in addition for customers. So that was a test that was done in Vereeniging. So we did a T3011. We did an ultimate stress test, just the bar alone. And then with a bar and a coupler and a bar. So, and that is what you want to see. You want to see the fractures in your bar and not in your coupler. If it pulls out of the coupler, the system fails. If you compare the two graphs, you cannot see any difference. That left one is without coupler, just the bar. The right one is coupler with 2 bars. You see, gives you the same curve. Then you do the bend and rebend test. So what they look at, if it doesn't break completely, what they look at in your test result is acceptable because no inclusions or cracks found. Then there is specific other tests that we did for some clients at the mine. So we used a 2-component resin, and we wanted to check what is the resistance and the strength that the bar can take. So they call it a short encapsulation pull test, shows 52 tons on a 1 meter bar. There's your graph there. Then if you now finally get the product, what do you look out for? What do you need to make sure that that specific product complies with your requirements? You can request a Sharpie test certificate, which looks like that. It gives you usually three tests, and then they use the average of that. Then you should always have a mill certificate. A mill certificate either for your coupler, but also for your bar, so basically for both key elements. So on your mill certificate, this is a coupler. It gives you the steel, and it gives you the standard that the steel complies with. On your bar certificate, gives you again the steel and the regulation. Then it gives you the composition, your CEV value. It gives you your tensile strength, your Sharpie values, and then your tensile tests. And that you should actually request for each batch, because with that, if you have a failure on your project, you should be able, with the supplier and the manufacturer, to trace back why did you have a failure. As Leonardo said this morning, there is an independent body that issues the approval. We have that also. So it's a German approval. We have a certificate of conformity that confirms that the material complies with the national technical approval. The German technical approval is issued by the German Institute for Building Technology, which again is part of the EOTA, the European Organization for Technical Approvals. So it gives you exactly what they look out for in the quality, what the system is capable of, what the compliance is. What they do is they monitor the production and the products on a regular basis. And that is just from their website to show you where the DIBT fits in the legislation. In summary, the term rock anchor covers a large variety of products and applications. Therefore, it's important that you use the correct product for your respective application. Temporary versus permanent strand versus bar, anchor, full bar versus SDA. You must understand your product so that you can do your calculations correctly. As we heard this morning, don't use the values and the calculations from one product, but then use a different product. It will not work. And very important, the whole system with all components must be suitable. So it doesn't help if you have the best netting of the world, but you use a substandard anchor. Because, I don't know how often you have seen failed rock protection. Usually, whatever I've seen is the failures in the anchor. Very seldom that the net actually breaks, but your anchors, either they fall out, they're corroded, or they break under the impact. So you need to have the correct characteristics for all systems. You need to make sure that the product complies with the legislation, and you should request all test reports and quality documentation to make sure you get what you request, so that your product is safe. Because we all know quality means safety. Thank you very much.
Thank you, Ansha. We're going into our afternoon case studies. Our next speaker is Mr. Dries Swart, who is a project manager at a company called Marshall Developments. He has a BSc in construction management from the University of Pretoria. His experience is in civil engineering construction. He's done, his first project was in a rockfall project in Chapman's Peak Drive in 2009. He also has mining rockfall experience since 2011. Some of the clients that Marshall Developments have are Fosco, Anglo Plats, Anglo Kumba, De Beers, Sasol, B2 Gold, and Semenco. So please put your hands together for Mr. Dries Swart.
Good afternoon, ladies and gentlemen. Thanks to Maccaferri for affording contractors like myself the opportunity to share a bit of the work that we do with the products that they so graciously manufacture and sell to us. This case study is for a draping, HR30 draping system that was done above access portals at the Otjikoto mine in Namibia, and the client was B2 Gold. This was the problem statement. You can see the areas highlighted on these various, on this photographs. There was a rockfall after a bit of rain in Namibia, and there was damaged infrastructure at the bottom, and this necessitated the mine to actually do something to protect the portal there. You can see the fall arrest structure there at the bottom. That was found inadequate for the type of material that was coming down during these rockfalls. This is a schematic of the problem areas. There was 3 areas right above the portal, just right off the portal, and then there's a small bull nose where the access ramp actually goes down to the portal, and then an area above the pumps. You can see the power lines and the pumps going down in that area where the drape mesh was proposed. This is just a close-up of the area above the portal, and to the left-hand side, and that bullnose area. This is where the pipelines were going down with the pump station and the electrical infrastructure at the bottom. As you can see, these slopes are quite high. 158 meters is quite a stretch to get a roll of drape mesh down. Here's just some key figures on the project. It was in total 156 anchors installed. It was just top anchors, as it is a drape system. 250 meters of top support rope, 19,875 square meters of mesh, and 250 meters of bottom weights. The client did their own surveys. You'll note that there's a discrepancy between the actual mesh applied and the calculation. The calculations does not take into account the undulations and everything that you have actually on the wall. On paper, everything is straight. In real life, it's not. Some key factors in the preparation of the site. This is done between ourselves and the client. It's removal of the loose material on the top bench for at least 5 meters from the crest, boring down loose rocks on the brow of the top bench so that when you lower your mesh rolls down, you minimize the dislodging of boulders while the guys are working there. There must obviously be access either by foot or by vehicle. There must be adequate space where you can see in this picture where you can put your rolls, your mesh rolls down so that they can be lowered. In some instances, we go down the face before we lower the mesh and just clean off the edges of the benches so that we don't put our people in danger when we lower the mesh. And as well, the infrastructure below, not causing more damage there. There must be an area for the equipment, obviously for compressors, vehicles, whatever that's needed on top of the bench. And then from our standpoint, you need to provide safe access for your people with adequate anchorage for the rope access systems for the guys to access the high wall. The hazards that's eliminated by a well-executed site preparation, you minimize the slip, trip, and fall hazard, you minimize rocks dislodging during the installation, and material, now speaking the mitigation material, falling down uncontrolled onto the high wall. This was the equipment that was required on the job, or the resources that was used during the installation. There was a site supervisor, 1 level 3 rope access technician, and 5 level 1 rope access technicians. So between 7 people, they installed the complete installation. Equipment, basically side vehicles, mobile compressor, handheld rock drills, rope access harnesses, hauling rope, climbing rope, rope access pulley systems, and a variety of small tools. The steps followed for the installation, the top support installation, you can see here with the anchors that Ansha has spoken about just now, with a top support rope that's installed. So the steps, setting out positions, drilling the holes, installing the anchors, and then also installing the top support rope as per the Maccaferri installation manual. Quality assurance during this process, we confirm the anchor spacing that it aligns with the design that was provided by Maccaferri and the design engineer. And we confirm that the correct hole diameter and hole depth is used when the drilling happens. Test cubes were made of the grout, so that was tested as per specifications provided by Maccaferri. And then we verify that the top support rope connections is done in accordance with the OEM manual. Now for the mesh, we attach the mesh to the top cable, it gets folded over, it gets clamped down on every single vertical cable with 3 rope clamps as per the OEM. And then we rig the mesh rolls up with a pulley system. Before lowering, there's hold points. We confirm that the mesh is folded over with equal spacing, that it doesn't do this while it's over the top cable, and then that the number of rope clamps is in accordance with the installation manual. Placing the mesh down the high wall, it is lowered in a controlled manner by means of pulley systems. The level 3 rope accessor, which carries the responsibility for all rope access rigging, he is the one that's responsible for lowering and controlling the speed of the lowering of the mesh panels. Then it is lowered into its final position, and once it's at its final position, bottom weights are installed. Here is supposedly a video, but I don't think that's going to work. Oh, there we go. Well done. I don't know if you can see, you'll see the mesh roll starting to move down. You can see that it happens in quite a controlled fashion. It's it's not just bumped over the edge and we hope it falls in a straight line. And there's constant radio communication so that everybody involved, your spotter at the bottom and your level 3 guiding the roll down, can make sure that it goes down properly. Okay, there you can see some pictures of the installed mesh, the bottom weights that has been installed in both these pictures. Then this is the final product. You can see mesh there going down, again, bottom weights installed. This is the area where the electrical cables and the water supply pipe is going down. And this is the area above the portal with that little bullnose going around the corner there on top. Quality assurance, it's done continuously throughout the project by ourselves and the project engineer. And upon completion, the installation was inspected by the OEM and the principal engineer that takes PI for the design. Then where the inspectors is not able to access due to them not being rope access qualified, we take photographic evidence and we present to them. And the project was signed off by the OEM representative, the principal engineer, and the project engineer as completed to the design specification, and the OEM installation manual and the client requirements. So all three parties signed off the project. This is a bit of a summary on the project. It was completed within budget, ahead of time, and with 0 LTIs. For a fairly unsafe work environment, we pride ourselves in putting safety first. The client commended the performance of the team, both in terms of safety and productivity. All health and safety requirements from the client was met and exceeded, and the project was concluded 13 days ahead of schedule, providing the client with earlier access, thus increasing productivity in the mine. This is just a little video showing a panoramic view of the mesh that was installed. Then just a couple of notes with regards to our experience dealing with the Maccaferri products on this specific job. We received excellent technical support from the day that the material specification was sent through to Maccaferri, detailed material breakdowns, costings, and that from a contracting point of view makes it a lot easier to put in proposals to clients and have accurate proposals to the clients. And I think that contributed very much to the success of this project. Thank you very much.
All right, thank you. Our last presentation from the day, for the day, there are two presenters. Between Davis and Christian, who's going to go first? You're going to do together. Is it you, Davis? Okay, so all right. So Christian, well, let me read both your CVs and then I'll leave you to do your thing, right? Okay, so Christian Meinhardt is the Director of Rockfall Systems for HG Geotechnique. He has a BTech, again, civil engineering. Christian has more than 17 years of work experience in design and construction in civil and mining engineering. You know, this is such an important thing for me. All the young engineers in the audience, you know, the most important thing that you need to do is to chase technical experience in your career. So I love what I'm reading about your CV, Christian. His career started in consulting in 2007, both in design and as a resident engineer on construction projects. He then followed his passion for construction projects and joined construction companies between 2013 and 2018, working as a contracts manager on multiple large-scale projects. For the last 5 years, Christian has been working as a rockfall hazard mitigation specialist and is currently the Rockfall Systems Director of HG Geotechnique. He's going to be talking about Gamsberg mine scaling and safe making of high walls, a case study. And then we have Davis Chilwane. Davis Chilwane is the acting rock engineer at Vedanta Gamsberg, a company joined in 2024. Congratulations. He's accredited with the Chamber of Mines Strata Control. He has a blasting certificate and is currently studying towards a rock engineering qualification. His career started on the gold mines with Gold Fields as a miner and then production supervisor. He moved to rock engineering in 2014, and in 2018 he joined Medindi Consulting, was promoted there quite rapidly, and more recently joined in 2024 Vedanta Gamsberg. Christian Mehnert, you're on the floor.
Thank you so much for the kind introduction. And thank you, Maccaferri, for arranging all of this. It's really an honor to be here today to present to you. And yeah, it's just wonderful to see some old colleagues, some old mentors like Joseph Meadows, and just to be in together with the rockfall specialists and the leaders in the industry of rockfall. It's always nice to see the smart engineers. At some point, I realized I wasn't smart enough, so I just jumped the ship and went to the contractor side of things. So yes, I'd like to present to you today a project that we did at Gamsberg Mine, which was over a period of 2 years. Gamsberg Mine is located in the Northern Cape. And yeah, so this is a case study of what our contract entailed over a period of 2 years. I'll go through the rockfall problem statement and the background. That is where Davis will also jump in and give you some background on the problems they faced at Gamsberg in terms of rockfall. Then I'll carry on going through the solution that was applied, our specific scope of works during the project, our keys to success. Then I'll focus on 3 areas that we know was very important during this project, which was scaling and cleaning, mesh installation, and then very important, the barrier installation, and just then summarize. All right, so I think you've heard a lot about rockfall today, and it's very clear that the main problem is that it presents a serious hazard for people, structures, and infrastructures. The phenomenon can occur in several environments, natural and artificial, and especially in open pit operations, blasting and bench deterioration can induce the detachment of rock blocks and compromising operations and operation safety. So to put it more basic, any type of fall of ground or rockfall in an open pit mine can be a risk to operators, driving the hauling trucks. You've got small LDVs moving, and you do not want to have any damage to those vehicles or even loss of life to the people driving those vehicles, and you also do not want to have any stoppage in operations. So there needs to be a solution to stop or minimize rockfall events. So in terms of the solution is for every mine to have to compile a comprehensive code of practice to combat rockfall, which then, if it's properly implemented, it would reduce the number of rockfalls you have on the mine. Each mine, as we know, has a zero harm target, And that is what we try to do as a rockfall mitigation specialist contractor. We help the client, we help the mine to install systems that gets them to that zero harm. And at this point, I would like to ask Davis to join and give us a bit of background on Gamsberg mine.
Thank you, Chris. Hi, everyone. Just before I go into the background, I think I would be doing an injustice to my Institute of Higher Learning because there's been a lot of talk about Institutes of Higher Learning. I also want to mention that tax of next. I think the previous speaker was also from the University of Pretoria. Yeah, so anyway, I just want to give background onto why we needed this project and what was the material impact had we not conducted this project. So Hof Geotech did the project for us. So basically, in terms of background, what you have here, this is site Gamsberg. We have two operating pits. We have the east pit and the west pit. This is the east pit, which is separated into 3 pits. That's East Pit 1, East Pit 2, and East Pit 3. And basically, can I just take this off? What we have is that this is the northern high wall where we had instability issues. And basically from the mine design, where it's showing there, that's the life of mine ramp. So basically when we're gonna open up East Pit 2 and open up East Pit 3, that life of mine ramp is going to service the entire life of mine of the pit. So we needed to actually stabilize that northern high wall. Otherwise, I mean, you can imagine the material impact if we do not stabilize that high wall. Another thing that we had an issue with is that when they did the initial open pit for East Pit 1, they had considerations of the trucks that they were using there were smaller, and then now as they upscaled, that the dimensions of that life of mine up ramp did not allow two-way traffic for the larger dump trucks that were now deployed on the mine, and also the incorporation of because what the standard says on this side of the ramp, you need a catchment berm and then you need a crest berm there. So the dimensions did not allow for that. So we had to actually come up with a plan. So basically by installing the barrier fence that Chris will allude to, we actually reduced or removed the need to install the catchment berm that is there. So the work that was done to determine the secondary support that is needed was conducted by Open House Management. That is a rock engineering consulting company. So what we then did is that we did field observations and kinematic analysis on where are the potential areas of instability. This entailed local mapping and analysis of unstable areas on the northern high wall. As you can see, the orientation of the geological structures on the northern high wall is very unfavorable. They all lead to potential for planar failure. So you actually always have these large rocks sitting on planes that may lead to planar failure. And also because of this orientation, what you get is that even if you've got rocks that have dislodged from the higher benches, that sort of like will lead to more instabilities. So what we then did was that we did a drone survey for all these areas of instability, and we categorized them into this color coding categorizes basically your blue points are points that we felt that these guys could scale and make safe. And then the green areas are the ones we could scale easily and make safe. The blue areas are the ones with the potential to actually land on the ramp. And then the red ones will be the ones that were very difficult to scale and make safe, and they will actually go into the ramp. So what we then did is that we just did a calculation to derive the mass and the cable requirements for those red areas. So when we did that, right now, just a crude calculation, we did not consider all the rock properties, and therefore it was conservatives. And then the instabilities that were difficult to support will be monitored. We've got monitoring systems on the mine for undue movement. And I mean, also difficulty to support is that to access those areas is not very easy. And also another monitoring thing that we do is that you install the prisms or the radar. But I mean, to also install the prisms is not a very easy exercise. So we then did extensive work with Hof Geotech to actually schedule the priority areas that require support. So this table is just showing you how we categorize. This is just the red areas that I showed in the previous slide, how we categorize them to say that that point number 2 was a risk of slabbing, and that's the block mass that could come up from there. So what we then did is that from all the red areas that I showed you there, we did some numerical analysis with Traject 3D. Traject 3D is just basically a 3-dimensional rigid body rockfall analysis program, and it's used to simulate the trajectory of volumetric bodies during free fall, bouncing, sliding, and rolling. So the limitations of the software is that the body is selected from a toolbar, and the size and function is selected will give you the geometry and the mass and the rock properties. So we then did the Traject 3D. So where we could install the barrier fence or the catch fence is on the geotechnical bench that we have, which is on 1035 level. So from the software, rigid bodies were dislodged from all the red category areas. And then we did a query that's placed on the 1035 level to understand the kinetic energy requirements. And then the result is that yielded is that the highest kinetic energy requirement was 84.2 kilojoules. And this originated from observation point 8 from that previous slide. So we were limited in the fact that because of space requirements, we could only install the catch fence at the 1035 elevation. So we determined the kinetic energy requirements at that elevation. So from the software, bounce heights were also used to determine the required height of the catch fence. And as you can see, the rock was dislodged from 1065, and then we looked at the kinetic energy. So this is the requirements that were needed to stop it at that 1035 elevation. And these were the parameters that were given to Hof Geoc in terms of the secondary support that is required. So yeah, that is just the background of the issue that we had. Thank you. I'll hand over to you.
Awesome. Thank you, Davis, for giving us such good background on the problem. So going forward, looking at the steps to successfully combat rockfall, we've basically covered the assessment, the analysis, and then the design that was done by the mine and then the consultant. And then the installation is where Hof Geotechnic comes in. So I want to focus on the installation and the installation methods and just point out some important things from a contractor's point of view, working with mesh and rockfall barriers. Just to give you a quick breakdown of our scope of work, we had to do scaling on the high walls as they determined on the different areas, the blue, the green, and the red areas. We had to do drilling and charging of rocks to be blasted. We had to do cleaning of benches. And this, to note, it's all been done by rope access technicians. We had a team of 10 rope access technicians on site to do all these work. As you can imagine, just to access the mine benches is very, very difficult. We also did installation of crack meters to measure cracks as they were forming on the benches. Prism installation, And as Davis also mentioned, we worked together with them on a day-to-day basis. They will identify areas that's priority, and our guys will just follow their instruction and then go out and install prisms when needed, or then when mesh is needed. So we had to really work together. Then I'll cover some mesh installation. So where larger areas needs to be made safe, the double twist and the steel grid HR mesh must be installed over the high walls in a drapery system. And then the barrier installation, as he indicated, above the main access road into the east pit, a 6.4 meter high, 750 kilojoule barrier must be installed. And then temporary netting, some of the areas had some temporary netting, and our rope access team was responsible for removing and installing in other areas as those areas became priority. So before the project started, we understood that this is a very, very sensitive and very important project for the mine, and we had to really plan the way forward before we even started or even stepped foot into the mine. So our keys to success is to have competent team members that's going to do the work, and that's all IRATA certified rope access technicians. We also do training for project-specific scope of work. As you might know, that you have to go through some training before you can work on the mine, but we even do training before that. So we sit down with our team members and we run through the whole project so that we make sure that the team is really prepared to go on site. We follow the IRATA International Code of Practice, which is for rope access. And then we had to develop a comprehensive quality control and assurance plans to cover all the different type of items we had in our scope of work. Then monthly key performance indicators was very important. We had monthly KPI audits to ensure that we were delivering quality work. Then there's also safety compliance, environmental compliance, statutory compliance, and then also regular inspections and installation guidance from the supplier, which is Maccaferri. And yes, they gave us wonderful support during this project from the get-go. And then obviously weekly progress meetings to ensure that we were delivering on the project. So yeah, just to quickly look into the training that we do, internal training as of Technique. We take our guys, we set a few days apart, and we work through the scope of work of the project. We go through the construction drawings and the project specifications. We look at the site conditions and the access. As some of you might know, on these mines, there is, the weather can be extremely hot. It can be extremely cold. So we need to really be prepared to go and work in those conditions. It's really, really not easy. We look through the installation manual that Maccaferri supplied for the barriers and for the mesh installation, and we ensure that all our team members are aware of how to install these. Then we also work through the KPIs and then look at special tools and equipment if needed. On this project, we could not use any cranes or any telehandlers to move material, and everything was done by hand. And that really was a challenge for us, and we managed to pull it off. Then we also just look into our method statements, and then very important, the rope access safety. Even though if you look at it, the rockfall is the problem, but now you put a team on there working in very difficult conditions, now you have another risk you're adding in terms of rope access safety. So you're trying to do or eliminate rockfall, but now you have another risk you have to deal with. So the rope access safety is very important. This was just the KPIs that was measured each month to ensure that we were providing the quality work. I don't think I'm going to jump through all of them, but there's safety, quality management, environmental compliance, our work completed, our employee compliance, and then statutory compliance. So we had to, we were measured to these on a monthly basis during the 2-year contract to ensure that we were delivering. At HG, safety is our top priority. That's why our rockfall rope access technicians are some of the most highly trained individuals in the industry. I think in this team of 10 guys that we have together, they almost had like 30 years experience between them in doing rockfall installations. So it was a very high-skilled team. Yeah, and they hold certifications, IRATA certifications. We had 2 level 3s on site, a couple of level 2s, and then a couple of level 1s. And yeah, they were all working together. We work according to 5 golden rules that just ensures that there's no incident working on the rope access systems. So always attach to 2 points when working on heights, your main line and your backup line. Maintain a full factor of 0. Use rope access equipment in the correct manner. And then also make use of rope protectors and sharp edges, and be a brother's keeper, so body checks. So to give you some idea of the scaling and cleaning, there's a couple of photos here just to show you how the rope access technicians access these high walls and how they'll push off some loose rocks that might be at risk of falling. So rockfall scaling is a technique used to remove loose rocks and boulders from steep slopes or cliff faces to reduce the risk of rockfall. So during this, obviously, there's a communication with the mine operations. When they push some of these rocks down, there can't be any movement or any activities at the bottom. So everything must be done safely, because that rock will land at the bottom and must be cleaned up. You can see here one of the guys being attached to the 2-rope system. So, and then more scaling and cleaning of benches. You can see that there's a lot of material on the benches itself. So this process needs to happen to clean the benches and to ensure that during blasting that none of these rocks fall over. So in this case, the ramp was just below here, so you can see all the loose material here. In this case, our guys are drilling into the rocks and breaking them into smaller pieces that can be managed and moved away. Drilling and blasting, we also assisted the mine on several areas that could not be accessed by the usual drilling team on site responsible for the blasting. We would help and we would drill areas for the blaster and then help the blaster up to the area, and then they will continue with the blasting. So the benefits of scaling, it's improved safety by removing loose rocks and boulders. The risks of rockfalls are reduced, which can prevent injuries or even fatalities in mining areas where people work or travel. Reduced infrastructure damage. Rockfall can cause significant property damage, including damage to buildings, infrastructure, and vehicles. Scaling a slope can help to reduce the risk of such damage by removing unstable rocks and boulders. It's increased stability is another benefit. Scaling can also help increase the overall stability of a slope or cliff face. So by removing the loose rocks, the remaining rocks are then less likely to move, which can help to prevent future rockfall events. Reduced maintenance cost. By proactively removing loose rocks and boulders, scaling loose rocks can help to reduce maintenance costs associated with repairing damage caused by rockfall. All right, so now looking into the mesh installation, I think you've seen a couple of these illustrations today. So basically, you get a simple drapery system, which is a passive system, and a secure drapery system, which is an active system. In this case, we used a simple drapery system, which is connected at the top, and we used a double twist and steel grit. I think in total, just over 40,000 squares or 45,000 squares of mesh in total was installed during this 2-year duration. So the simple drapery means literally that the mesh drapes over the rock slope so that falling debris is contained behind the rockfall netting, and it is allowed to fall to the foot of the rock slope in a controlled manner. It also breaks the speeds of the rock falling behind the mesh, and yeah, it just helps to control the rock. The double twist and steel grid HR mesh is a tried and tested cost-effective solution. We've seen today how these meshes are tested and certified, so we know it works. Each simple drapery system was designed to site-specific conditions, the slope inclination and height, rock friction angle and weight, etc. So in that case, what needs to be determined for a simple drapery system is your anchor type and your spacing, typically 500 MPa thread bars, 2 to 4 meter spacing on top of your bench. Your anchor depth and diameter could be around 3 to 4 meters deep. This is just typical values, 25 to 40 millimeter diameter anchor bars. Diameter and steel grade of your top rope, it's typically 20 millimeter steel cables, but it will all depend on your site-specific conditions. And then also what is determined is your tensile strength of the mesh. And in this case, Maccaferri also gives you very good assistance to the client when determining what is the best solution for your slope. In our case, we didn't have only one area we had to install. There was different areas. So each area had to be specifically analyzed and designed for. So the advantages of the double twist and the steel grid HR mesh. The double twist is cost effective and for moderately steep slopes. It's light and easy to install. It's flexible and can conform to the rock slope. The wire does not unravel when the wire breaks. And like you've seen before, there's also various coatings available depending on the environment. Then steel grid HR, which is a hybrid mesh or geocomposite, where you have the mesh which is reinforced with the cables, which is stronger, and then very good for higher slopes. And it's when increased loads are expected due to debris quantities building up. It's got a high level corrosion protection and a high punching resistance. And as I said, as the inclusion of the steel ropes enhances the transfer of loads from the mesh into the anchor system on top. So first of all, you need to install your anchors at the top, and we'll get to some photos just after this. You'll have to install drill for your anchors, install your anchors and grout your anchors on the top as per the design. There will be a spacing that is required and at least 2 meters behind the top of your crest. You have to install this in a straight line and ensure that your grout is also tested to see that the MPa is according to the specification. In our case, we didn't have any bottom anchors, so it was an open system at the toe with just weights, bottom weights installed. So once you have your anchors installed, you can then temporarily just connect your top rope, and you can start placing your mesh in line, and then start moving your mesh down the slope while it's temporarily connected. And then while you're on the slope, you can start moving your mesh so it aligns. And that's quite an important step. As you know, the slope is undulated, it's not even. So when you start installing from the top, you quickly realize that gaps form between your rolls of meshes, so that you have to just move them around a bit. And if it's permanently connected then on top, it's very difficult. So it is a challenge to get that right. Very important considerations for us as the contractor is receipt of the materials and the storage. So once your mesh is delivered on site, to me it's very important. That's where your quality control starts. So you as the contractor needs to go and make sure that there's a proper space for the material to be stored. You must check each roll and count each roll to make sure that everything is there. So over a 2-year contract or period, we were not installing all the time. So sometimes we'd be doing something else, and the mesh would be, we were not installing mesh. But you still have to know exactly what's happening with the mesh. Someone might come around and maybe just pick it up and go and use it for fencing or something, and the next time you get back, your mesh is gone. So to me, that's where the quality control starts, so it's important to check that your material is correct. So access to slopes and logistics. As I mentioned, in most cases here, no cranes or telehandlers were available, and we could not access the benches very easily. I'll show you some photos. We had to, with pulley systems, pull the mesh rolls up to areas on the high wall. The clearing of the slope face and crest of loose material before any work can start is very important. Setting out of your sights, your anchors and your rope positions according to design. Installation of crest line anchors, your drilling and your grouting. Lifting, placement and temporary securing of the mesh. We used a top-down installation. We first had to pull all the rolls of mesh up to certain benches, and then use the top-down method to install the mesh rolls. So then the installation of the crest line rope and rope terminations, that's also very important. There's certain standards in terms of your rope diameter, how you must do your rope connections to your anchors, which is very important to follow. And then adjustment and permanent connections of your mesh, like it's shown here. If you don't want your mesh to overlap like this, and therefore it needs only to be at first temporarily tied at the top, and then you can be able to move it a bit, and then when it's straight and joining to each other, then you can permanently connect it at the top. So just to show you, I think looking at this slide, I'm not sure if you can see it properly, but this is our guys pulling up a roll of mesh a couple of benches high. We couldn't get any other access to that bench, so this is how we had to pull up rolls of mesh, and you can imagine this is very hard work and very tedious. This is just another example of the top anchors that we installed. And you can see that your front edge of your crest is not in a straight line. So immediately you need to understand that your mesh is not going to cover it exactly. So you have to work according to the actual site conditions. And then on the far other picture, you can see the DT mesh being installed on the slope. Then jumping over to the barrier installation, this is more or less the position that the barrier, rockfall barrier or the catch fence was to be installed. And just to give you some idea, I don't know if you can see it over here, but there is our team busy with installation of mesh. So they were really working in very, very tough conditions. And there was no access from the top. At that point, they weren't allowed to, there was an access road, but they weren't allowed to use that access road with vehicles. So the guys had to make their way up there with rope access techniques. So basically just to show you the position of the barrier and to show you where the access ramp was into the pit. And as Dave has explained, this access road is there for a long time, so it is important to protect this access road. So what is the advantage of barrier installations? Where it may not be optimum to install rockfall drapery protection, a cost-effective solution is installing dynamic barriers. And with the assessment and the analysis that the mine did, they found that a barrier is needed on that bench to intercept any falling rock. It's also good for areas where larger impacts are expected. And as seen before, it's tested and certified barriers, and generally the best performers on the market in terms of residual height and elongation. And yeah, this was very important as we started out, we had to present to the DMR in terms of the barrier, and they had extreme concern about the barrier and the performance of the barrier. And luckily, with all the testing and the certifications that the barriers come with, it can be proved that the barriers can work. So after a couple of presentations and working together with Wynand on this, I think they were happy at the end. The engineers can perform a rockfall trajectory analysis and determine the suitable fence type in the most appropriate location on the slope. And that's exactly what they did. And in that case, they found that they need a 6.4 high meter RB750 dynamic rockfall barrier. And for us, that was a very, very high barrier. And I think one of the highest installed in Africa or South Africa. It's easy maintenance of the impact. And the rockfall barriers are supplied in kit form, with installation manuals for easy installation. So we've also seen this illustration before. Basically, that is the type of barrier kit that you'll receive depending on your length. This one could be, let's say, if your interception structure is 10 meters, this one would then be 30 meters. We had to install about 370 meters on the east bench, and to date, we completed about 100 and something meters of that barrier fence. Just to focus on the quality control as well, we developed an installation checklist for each and every aspect of the barrier kit that went together with the installation manual that Maccaferri provided. So that was also very important for us to be able to install this barrier successfully. This is our team doing the installation of the barrier. The access road is just beneath them. And yeah, it was very important. We had a couple of site visits that we had to do to get this right. And again, thank you, Wynand, for the assistance that you gave us with this. As soon as we started with the layout of the barrier, there were some challenges in terms of aligning the base plates. There was a lot of level changes between your base plates and alignment. We couldn't align it in a full length, so we had to break it up in certain lengths so that we can line certain barriers up 100%. There was also not enough space for the upslope anchors, so we had to adjust that a bit to make sure the upslope cables could be installed correctly, and we had to look at a little bit of a redesign on that. One of the other main things is that at the bottom of this is your access road. We could not get this material up with a crane at all, so our team had to lift ring panels. You get them and they're bunched together. It's very heavy. So our guys had to use a pulley system to get this material onto this bench. Some of the posts could be delivered to the far end, but had to be carried up the bench quite a long bit. The problem with the crane was that the access road was too steep, and then there was no way that the crane would be able to work on that area. So yeah, I think if you look at this pictures, you have to get some respect for these rope access technicians working in these type of conditions. If you look at that post, that's 6.4 meters high. Our guys are there working day in, day out to get this barrier installed. The barrier posts, which is usually also lifted in place by crane, could not be done, so we had to do it by hand. That means we had to use some hand tools, chain hoists, and turfers to pull these posts into position and lock them into position. Here you can see the guys have now done the ring net panels, the interception structure, and then there's another layer of DT mesh that is being installed on the ring net panels. So just, yeah, in conclusion, what is very important on a project like this is the installation teams must be trained on installation methods. It does not help if the site assessment, the analysis, and the design is really good, but then you have a weakness in your installation. So the installation guys must be trained and very competent in the installation methodology. Your rope access also needs to be according to International Code of Practice, and no shortcuts can be taken. So very important in terms of safety. The quality assurance and control plan is very important. That needs to be followed for each step of the installation, even if it's prism installation or scaling and cleaning, it all must be done safely. Access to mine benches must be properly planned. During this project, we just had a lot of challenges with the access to the slopes, and that must be planned ahead in terms of time. If it's easy to access and you can place your mesh rolls, and then you can just install and lower them down. But if you have to start pulling up every mesh roll, it takes time, and that also, your end result will be much longer than anticipated. Your correct tools and equipment for the work is very, very important. And then the synergy between the contractor, the supplier, and the client is key. We had a very good team working on this, and with the help of Maccaferri, we really gave the client some good solutions and results in terms of the rockfall. Regular inspections and site visits was very important. Regular production meetings and online meetings. And yeah, the rockfall mitigation measures that we implemented over the 2 years resulted in a huge reduction of rockfall events. And that also enables the mine to look at this data and see in these 2 years what happened with rockfall events versus the previous years. And that data they can continuously collect and compare to previous years in terms of how many rockfall events happened. Then just, yeah, the importance of rope access safety is very important. And for that, I'll just like to give a shout out to Sonny Boy. Where's Sonny Boy? So, yeah, thanks, Sonny Boy. Yes, your team really did an amazing job here. Thanks. Thanks, everyone.
Don't leave the stage. We do have the luxury of time. I want to do the same thing that we did previously. Davis, do you want to come and join us as well? Let's field a few questions. So while we're doing that, Davis is getting ready. Please think up your questions, get them ready. You know, you guys were punting University of Pretoria, and you and you went yay in the corner there. So, so hey.
Trying to give him some support.
Yeah. So I, you know, being a civil engineer and in that space, we had this discussion where we were looking at the data of all the number of professionals that were leaving South Africa. And a lot of the graduates, well, they were like, you know, between 5, 10, 12 years of work experience at the prime of their careers. We're leaving, going to Canada, Australia, New Zealand, and there were more numbers going to New Zealand and Australia. So we were looking at the data, and we didn't know what to do with this. And we said, somebody was asking the question, what on earth are we going to do with all these UP people, these Turks that are leaving to Australia and New Zealand? And I kid you not, this came out like that. It says, I said to them, just leave them, let them go. They are raising the average IQ of both countries. All right. I said that while you're on stage, so obviously there must be a retort somewhere. Okay, but let's get to. I loved what you presented. You know, I didn't even know there was such a thing, a career in rope access a rope access technician as a career. I'd like to hear more about that. And then I also want to learn more about the actual experience that you had with Maccaferri. You know, in terms of the products, the quality of the products, the delivery, the rendering of service. You know, there's nothing more beautiful than to see the engineering team, which is the consultant, the client, the contractor, and the manufacturer, come together to deliver a world-class project. In my short stint in South Africa, I've observed that we do incredible work as South African engineering teams, and we don't necessarily get that recognition here at home. We are world-class engineers delivering world-class projects, working with companies like Maccaferri. I want you to touch a little bit on that. Let's start off with the second question first. Your experience with Maccaferri, what was it like, and give us some detail.
Yes, no, thanks for the question. I think from the get-go, it was really good. I luckily worked for them as well for a couple of years, for 3 years, and so I understood what was needed. And then Wynand from Maccaferri was then the technical support from their side, and yeah, we were just on the map from day one. And in terms of the technical support, they helped us extremely a lot with even site visits. We both went up. They pulled us up on the benches with the rope access to go and do inspections. And Wynand would be all over the place marking out positions and rope or for the upslope anchors. So yeah, there was not one day that I couldn't push on his button and he won't reply. So he was always there, willing to assist. On the mine side as well, I wasn't always included in terms of all the meetings as they were supplying the products directly to the mesh, and we would just install. But materials were always there. We were never waiting for any materials to be supplied. Obviously, in terms of a barrier, there is a period that the barrier needs to be manufactured. It's a customized barrier, so that will take long. It takes long to ship from Europe. So, but the client was aware of that. So obviously, in terms of that, there is a lead time in supplying a rockfall barrier, but that is a norm. There's nothing strange to that. It's not seen as a delay. It's a lead time in supplying such a big and long customized rockfall barrier.
Mm. And obviously from the client's perspective, yes, you rely on your engineering team to deliver your perspective of the experience with Maccaferri?
Look, like I said, I recently joined the company, so it was a legacy project that I got. I got it into its final stages. Okay. But when you got to the project, what you then look is what was being done, basically. So basically, the performance indicators was in the monthly KPIs that they were measuring these guys on. So basically, looking at that history, I saw that they were delivering the project in time. They would have isolated areas that were not in scope. And I think he mentioned earlier about the blasting of the secondary slopes that required remediation. That was not actually part of their scope. So, I mean, they did that for us. I mean, and so that will actually take the KPIs higher. So, I mean, when you've got a contractor like that on site that delivers and actually goes above and beyond in areas where it's not part of the scope. So I think it was a very good experience to work with them.
Excellent. Davis, while you've got the mic, you mentioned earlier about drone imaging and identifying zones of risk in terms of rock falls and so on. I couldn't make the connection between taking pictures with a camera off a drone and then identifying where the risky areas were. Just take us through that so that there's a bit of clarity.
So basically what happens when you do structural analysis where you can actually access your areas, you do your structural mapping. So this informs your structural orientations, your joint sets, where you've got areas with potential planar failures or something like that. But now in a legacy project like this where you can't access these things, so what we do is that we'll fly the drone and then we'll take, they call them ortho photos. And then from that, we can actually do structural mapping from the drone images and actually identify the potential areas of instability. So it's basically just to access areas that you can't.
So it's pure pictures, like we would take a picture on a cell phone.
Yeah, it's pure
pictures.
pictures.
No radar technology or heat emissions or anything of that sort.
No, it's just pure pictures that you'll take. Yeah.
Okay.
But you actually do incorporate that with the radar. So we have radar monitoring. So what we'll do in terms of calibrating the pictures that you get is that you will look at that specific area and then calibrate that with what movements are you getting from the radar, and actually say, okay, what the picture's telling me and what the radar's telling me is actually a true story.
Okay, all right. Back to you, Chris. My last question is, give us briefly, I have never heard of a rope access technician. And it's incredible that we are engaging with careers that we never knew of before. I'd imagine this is an old career. You know, we talk about AI and new careers coming out of that, and the technical space in terms of AI and so on. Tell us quickly, very quickly, about what is a rope access technician, and you mentioned IRATA, which is some kind of accreditation association. Yes. Would you just tell us about that?
Yes, I'm actually very happy that you're asking this question, especially that there's young students here. And I would really recommend to the young students here to go and look into it. I mean, me as an engineering technologist would love to be able to access a site. Even if you get your level 1 rope access, then you'd be able to abseil and go and look at these areas. And in America, it's almost for all the guys working in these conditions, they all have their IRATA level 1 or level 2 or level 3 certificates. So the engineers actually have those certificates, and for them to do the assessment, they actually have to go onto the slope and do it. I know there's new technology like the footage, but it's very important coming to inspections, going to look at anchors. If it's not accessible, there's no access road directly where it was installed, you can then be able to go down using your rope access training and go and inspect areas. So for all the students out there that likes the outdoors or likes to try to do the contractor side, or even the engineers that needs to do inspections at some point, definitely look into doing your rope access training. So basically it starts at a level 1 and goes up to a level 3. Your level 1 is when you do your first training. Then you need a couple of years experience as a rope access technician, and you need to have a logbook of all the hours that you've worked on rope access. So once you have enough exposure and enough experience, you then also have to do training as a level 2. And only after you complete that and you pass that, you can become a level 2. And then you can become a level 3 as well, which is your highest, and then you become a rope access supervisor. So there must always be a rope access level 3 when there's work being done on a rope access. So he needs to look at the whole team's safety. He needs to look at all the connections or the rope access connections they're doing, the abseiling, all the equipment that they use to rope access. And for him also to get into that position, he needs a couple of years experience as that after he's done his level 2. So after a couple of years that he's done he's got experience as a level 2, he then qualifies to go for examination as a level 3. And when he or she passes that, he or she would become a level 3 rope access technician.
Okay, all right. Fantastic. Questions from the audience? If you just raise your paws, and I'll try and get a mic to you. Any questions? No? Going once? There's a question out there, yes?
Good day, everyone. My name is Daniel Molfitsan-Likitlane from
Why don't you speak a little louder because the speakers are facing forward.
Okay, no problem. I am a student at the University of Johannesburg doing civil engineering technology. Right, so I have a question for Mr. Maynard. You mentioned at one point that the DT mesh was installed using pulleys. So I want to know, is that the most efficient way of installing them, time-wise and most definitely safety-wise?
Yes, thanks for the question. It's definitely not the best solution. In the best case scenario, you have access either to the bottom of the slope or the top of the slope where the installation of the mesh needs to take place. When you have a couple of benches and there's an area in between that you have to do, it means you can't access directly from the top or directly from the bottom. So you have to do this pulley system to get your rolls onto the area or the top bench or the crest where you need to start installation. So this is very time consuming to do that. Not all the areas to us were like that, but some were, so that really is a time consuming activity in terms of pulling up each roll one by one. That roll weighs about 200-300 kilograms. So that is quite a weight for the guys to be pulling up such a big roll of mesh. And again, hats off to the guys doing these type of hard work with pulley systems and getting the mesh up to the area. And in terms of safety, the rope access technician, level 3 supervisor would also always make sure that work is done in a safe method or safe operating procedure. To ensure that there is no accident or any incident that can occur while they're doing this.
Okay, no, thank you so much.
Yes, ma'am. A mic out here in front, please. Just give us your name and then you can ask your question.
Good day, everyone. My name is Aphelele Mbata. I'm a student at Wits University. I'm here with SciC. I have a couple of questions. I don't know if it's stuff that I missed on the presentation, but I would like to ask, how do you choose between using a mesh roll and the barriers when you're putting in the stuff? And is there like a slope stability? Oh, let me place it right. In mining, do you do slope stability before you do the beds, or is it like you see afterwards and how the slope will fail?
I certainly hope you don't do it and then we'll see afterwards.
Yeah, I think I could maybe talk to the first question and then maybe you can talk to the second one. During the assessment and the analysis stage, they give consideration in terms of what will be the best solution. If it's drapery mesh, you also get secure drapery mesh, which is then pinned into the high wall or your slope, and then the barriers, and then you also get the larger embankments. So it's all about the slope conditions. So if you have really big boulders on your slope that can move, then it might be that an embankment that can take more than 5,000 kilojoules of impact is your best solution. And so basically the assessment and the knowledge of the engineers then to go out and do the assessment and the analysis would determine what is the best solution. A very important thing as well is what is the risk at the bottom of the slope. If you have an old beautiful castle that's at the bottom, you want to have your best solution put in place to protect that from any rockfall events that happens. So there's a lot of factors that goes into the assessment and the analysis to determine what is going to be the best solution. Sometimes it's only cost driven and you look at what is the best in terms of cost. Sometimes it's time driven. You need something that's going to work the next week. So then a barrier is not a good solution because a barrier takes a longer time period to manufacture. If you have mesh, you can then install the mesh and you can at least then provide a solution in that way. So it depends on a few factors, if that makes sense.
Happy? Okay, colleagues, let's take our tea break. And
I think,
sorry. I'm sorry. Yes,
no,
please
it's
go
fine.
ahead. I didn't see you.
No, I think your first part of your question is, do we do slope stability and then determine afterwards if we need mesh? Yeah. Okay. So I think like this mesh installation is actually secondary support. So basically, when we speak about slope stability, I mean that's a whole another topic on its own. I mean that speaks into design of the mine. So if actually the design of the mine, where you consider, I mean, your kinematics, you consider your geology, you consider your lithology, all of that goes well, and you design your benches for your overall slope angle correctly, your blasting is done right, your pre-split is done right, then these guys would be out of business. So that's actually where your slope stability comes. That is actually your first point of attack. Now, when those things go wrong, then it's when you need your secondary support.
Okay, let's take one last question before tea break. Yes? Same thing, just stand up, tell us your name and the company you work for, and then...
Hi, everyone. I'm Karabo. I'm from the University of Johannesburg. I'm currently studying civil engineering. So the question I have is, what was the factor of safety that was used when designing the mine, and what was considered? Like, for instance, was it, when designing it, did you guys consider things such as the weather, so that you are able to ensure that material is stabilized and all?
Thanks for the question. I cannot talk too much about the design, as we were only involved in the installation part of it. I think you did mention who was the consultants that did the designs. But yes, there's a lot of safety factors in the design. From mesh installation, there's various areas that needs to be, safety factors that needs to be taken into account in terms of your rock conditions, in terms of your anchor that you're installing, your top rope. So in all basically in all aspects in your design, safety factors are taken into consideration, and yeah, there's always different, and there's guidances on safety factors to be used in the design. Unfortunately, I cannot tell you much more than that, because that was not part of our scope of work in terms of the design.
I think just to add on to that, there's different types of safety factors. I mean, there's the safety factors of the manufactured equipment. That's the OEM, they can speak to that. And then there's safety factors in terms of that when you speak about design, like I showed you there, what we did was that we did a trajectory analysis. And with the trajectory analysis, we looked at the potential kinetic energy at that bench that we want to arrest. So in that instance, it's not a safety factor parameter that you looked at. You actually looked at the kinetic energy that needs to be arrested. I mean, but then again, with your safety factors, that's where you look when you do your initial slope design in the mine to say, okay, and then you'll have your acceptable parameter, which is usually 1.3 and above, and you'll design your benches accordingly for that.
Okay. All right, let's call this session to a close. For the session after tea break, I'd like to host a panel up front with Blaise Jacobs from Maccaferri, Leonardo from Maccaferri, and I'd also like to invite Dr. Anshe Higo as part of the discussion. And let's try and give you some hot questions. And also, if you remember, to respond, to ask questions in relation to the presentations they made. Shall we say that we scheduled to come back at 16:25? Could I request that you come back at 16:15? 16:15, is that adequate time? Okay, all right, let's do 16:15. Enjoy your tea break.
Sentez-vous la mort? Moins que la solitude. Priez-vous? Ah oui, parce que je comprends la
Yeah? Okay. Okay, welcome back, ladies and gentlemen. Can I ask to come a little forward? A colleague sitting in the back, please come forward. We can make this as intimate as we could. Okay, Blaise is here. Leonardo. Antje. Fabian? Fabian is here, okay. Yeah. Yeah, you guys can sit comfortably on that end. Okay, is everybody mic'd up? Okay, we've got a half an hour we've got I mean, you've seen the presentations, very high level, tremendous deep engineering, all of it combined together. So we have people that have high level experience, high point of view, 30,000 feet, as well as down on the ground. So for this session, please can I ask you keep your questions succinct, be quite pointed in what you're asking, and we are certainly expecting the high level questions, the heavy stuff. I'm going to give each of our panel members 30 seconds for a quick summary of your presentation and what you and what you'd like the questions, what questions you'd like to be fielding. Let's start off with Fabien. 30 seconds, Fabien.
Okay, thank you. So my presentation was on the new alert system HelloMac. Just a quick summary. So it's an alert system with two options in terms of network coverage. Okay, so GSM and satellite. No need any wiring. Free battery with a lifespan of 5 years. Easy to install. So the perfect solution for our customers.
HelloMac. Blaise.
I just want to say is it on? Yeah.
Yes.
I just want to say thank you guys for the kind attention. My presentation was on rockfall mitigation products, just an overall summary. I hope it gave you some indication of the range of products that Maccaferri can offer. And we didn't touch too deeply on the technical design side. And if you're not sure, I hope that Maccaferri are able to guide you in this aspect, and we're able to guide you on which type of product is suitable for what kind of application.
Thanks, Blaise. Leonardo?
Yes, thank you. My presentation, as you remember, was focused on quality. So I tried to put the stress on the importance of quality, both in terms of design and in terms of material selection. So if you have any question about the design and installation and in general, quality issues, please ask.
Thank you, Leonardo. Antje?
Yeah, my presentation was about anchors, and I thought, or I hope I stressed how important your anchors, your anchoring are for your rockfall. It's basically your second leg that you need to give as much attention as you do give to the netting. And as Leonardo said, the quality of your material and the correct choosing of your product is important for success.
Antje, I want to start with you. There was a trend that I picked up in some of the presentations with Christian, with yourself, and some of the other colleagues that we interviewed outside. We were talking about the relationship or the experience that you've had with the Maccaferri. And even as professionals, we want to work with people that we enjoy working with. just touch on the relationship that you have with Maccaferri and your general experience working with Maccaferri.
The relationship is twofold. The one part is personal. I mean, I know Wynand for many, many years, so I have high respect of him. He knows really his anchoring and everything inside out, same with Joseph. The second part is the more professional part. Both companies are European-based. We based in Germany, the Titans. So from that point, there's already a link because there have been projects between Titan or Isabek and Maccaferri in Europe. And we try to build up the same in South Africa or in Southern Africa.
Excellent. Colleagues, this is your opportunity to ask some good questions. Let's start fielding questions.
Don't be shy.
Yes. Usual, just tell us your name, the company you work for, and your question.
Hello, everyone. My name is Jay Krishnan. I work for Maccaferri. My question is to Leonardo and Dr. Anche, because you were talking about rock anchors. So, in terms of design of rock anchors, how is the anchorage length is calculated? And is there any fundamental difference when you design a concrete anchor versus rock anchor? Because many times I've seen that the depth of the anchors in the concrete is shorter than the anchor length in rock. So if you can throw some light into the design aspects of the rock anchors, that will be helpful.
Yeah, actually the anchors, we have several software in our portfolio of software which give all the client, all the designer, the opportunity to calculate anchors. The way the anchors are calculated, there are many factors we have to consider to calculate an anchors. We have to consider the resistance of the anchors and, of course, the action present on the anchors, okay? So the resistance in this case are given by the tensile strength of the anchors and also given by the friction in between the slope, okay, and the let's say the grout that we use to fix the anchor inside, because there are some friction activities inside the anchors during the, let's say, tensile movement of the anchor, the extraction of the anchor, okay? So these are the resistance, this is the resistant part of the anchor we have to take into account. The second part is is the action. Actually, we consider, we have to consider the part of weather rock, let's say the part of spoiled rock, where the anchor doesn't have any, let's say, any anchoring, I would say, any anchoring base, so it's not anchored inside. So we consider the part of stable rock where the anchor will be anchorated. Okay, we consider the action on the anchor, then the part of stable rock in which the anchor is anchorated, and we calculate the action, of course, and we compare the resistance, I mean the friction angle, the resistance of the anchoring system in general, and we get the safety factor, making the ratio between the action we have and the resistance that we got using the material that we used inside the design. The theory, of course, I cannot explain here the entire theory that we use to calculate this kind of anchors, but if you are interested on, let's say, the methodology we usually use to calculate this kind of structure, I can give you a suggestion. We have a software that we use to calculate this kind of structure. The software are equipped with manual, with the theory inside, so you can easily download all the different manual for the software that we use. You can find there all the formulas, all the things important to make, let's say, a good calculation of anchors and of netting system too. So if you are interested, you can use our software, our database, our website to download this material to be, let's say, more familiar with this kind of calculation. But we make calculation, we have software to make this calculation. The theory, more or less, is what I said before, but to go into detail is better to have a sound basis on which you will base your calculation.
Sure. Is it also not because the concrete characteristics are predictable, the inputs
yeah.
Whereas on a rock you don't. You
yeah.
know as little as possible.
Actually, during the calculation we have, let's say, a diapason of different solutions we can take from. For instance, in our software, we have different rocks we can choose from, and every single rock has the different mechanical characteristics we can use to calculate the anchor. And this is the same for the grout that we use. If we use a grout with a certain, let's say, compressed strength inside the software, you put this calculation, let's say, data, and the software easily calculate the tensile resistance of the entire system.
Okay, Antje?
Yeah, if I can just add, specifically for your hollow bars, the first thing that determines your design is your soil. So if you have hard rock, you basically physically anchor the SDA in the rock. So your anchor can be shorter because you don't purely rely on friction. While if you have soft soil or sand, you don't really have anything for end anchoring. So your hull resistance of the anchor relies on the friction over the full length of your bar. So, and the second part is you use the different diameter of the bar. So the SDAs, you can have a outer diameter of 30 up to an outer diameter 227, even up to 196. And then with that, you have a different cross-section of metal, of steel, and you use all of this together with your required load and the relevant safety factor to calculate the length of your bar. We also have a system or a calculation system on the website. It's called Smart Titan. So once you're registered, you have access to that, and then you just give all your parameters. You load that into the software, and then that assists you with calculation of the correct bar and even the correct grout body, because depending on what diameter size of drill bit you use, you widen your borehole, and then your grout body has a different size, and that determines also the length of the anchor.
Yeah, another important figure to calculate properly the anchors is the shear stress of the anchors. Because when you have a weathered part of rock, you can easily understand that this part is bound to slide down. Okay, so the shear stress of the anchors is also important to be taken into account to properly calculate the anchor. And today we've seen from your presentation how important is the resistance of the anchors in terms of shear resistance. And this is also taken into account for rock stabilization using anchors, netting systems, general complex system to stabilize this kind of structure, this kind of slopes.
And that's why I was making the point earlier about the lack of prediction. On a rock surface, you don't know, so therefore you want a greater surface area to improve your resistance. So, sorry, I interrupted you.
The one thing that you can also consider is if you want to work with cement grout, and usually we work with 35 MPa, and nothing lower. But if you have really very brittle rock and very difficult soil conditions, like we sometimes see, especially underground, you might want to consider fast-setting resin. So you install your anchor, you inject resin, and with resin chemical grout.
Stabilize the slope and reduce the action.
And with that, you can actually pump it with up to 250 MPa. So you have MPa. So you have a very high pressure pumping that in, and then the grout doesn't just fill the hole and stabilizes your anchor and creates a shear force, but it also penetrates your rock fissures. So that's what I showed in the presentation with the TPM mine, where you basically glue, if I can use that simple word, you can glue the rock together and make it more stable.
Yeah, I want to bring in the Maccaferri specialist into the discussion. What role?
I have one comment on the anchors, if you because I have a little bit of experience on this. One advice is also to do some preliminary pull-out test, okay? Because usually you do some designs, and it's important when you are at the project start to have the company, the machines, everything that they use to do the project, because it's a combination of the product, of the methodology, of the skills of the workers. Okay, so it's important to do some preliminary pull-out test to check the characteristic of the soil. Okay, and as we mentioned, I mean, anchors is sometimes the weak point of the solution. Okay, because if you have the best barrier that you can have, the best test, okay, the crash test is perfect. But at the end, the barrier is anchored with weak points. It will not stand the energy. Okay, so it's very important for the customers, for the designers to check this part of the design. Okay.
Yeah. Does Maccaferri, in any of its subsidiaries or offices worldwide, did you get involved in this process at all?
Yes, because we have in some countries also companies doing the installation by ourselves. Okay, as Maccaferri, because there is no existing skilled team in some countries doing this type of job. Okay, I can mention Peru, we have one subsidiary which is doing installation as Maccaferri. In India also, we are doing our own installation. So we have the knowledge also inside in the company to do installation if need. Don't want to be here, it's not the case in Africa, okay? We have good partners and they are very skilled. In some areas, it's not the case. So we are doing this type of work, of course.
Okay. All right, thank you for that question. Let's get more questions. Colleagues? Can I get a mic onto the side?
Safety factor.
Hello,
Safety factor.
so I'm Joseph Meadows from Maccaferri. My colleague, Wynand, who's our rockfall specialist, had to step out.
I don't
So a question to the team, which the answer is quite simple. Leonardo, I believe you'll be here on Friday for the focus room. And Ansha, you'll have a couple of guys here for the team. And the focus room is aimed at any of your detailed questions where you can unpack the thing, touch the anchors, touch the rockfall. Hopefully we can touch the Hello Mac as well. So just perhaps tell us what you're going to do or what would you like to do on Friday with the focus room, and to encourage all the attendees to register for it. Then these guys will be ready for you on Friday. It's going to be in another venue, in smaller venues. So all the disciplines in Maccaferri is going to have a separate room. There's going to be a separate room for rockfall, and those experts there are going to have people available to answer your in-depth, nuts and bolts, unpacked questions. Can you perhaps just say what you'll have available on Friday, please?
Very quickly, please, Ansha.
We will have a few samples of the different anchors, the different sizes, the couplers, some brochures, especially also for the mining and slope stabilization, where we can go into more detail of the different products.
Leonard?
Yeah, we can begin, we can continue our discussion about quality, but also if you are interested in the process of designing or installation, we can discuss without any problem, ready to answer to your question.
Excellent. My colleague from Cat Mining. Yes, can we just get a mic here? Red shirt, yeah.
Thank you. I think you know I'm Kurt. Joseph just actually said that the discussion will be in a smaller group, but I think not all of us will go there or want to go there or will be able to go there. So I have one question for Elsa. It's about the Titans.
Just speak a little louder.
Sorry.
Yes.
I have a lot of experience with drilling, but I've never done Titans before. So my question is, as I understand it, while you are drilling, you are pumping the grout into the hollow bar, and it comes out at the end of the rod. My question is, where does your aggregate that you loosen while drilling, where does it go? Because it tends to clog and jam on the drill bit. And how do you get that much pressure in the drill bit or through the hollow bar while you are drilling? How is that done?
Fantastic question. Thank you for asking that.
So the installation process requires a top hammer drill rig. If you drill with cement grout, you have a drill rig with a top hammer installation and a flushing shaft. That flushing shaft is linked to the hollow bar. You have a combination with your grout pump. While you drill, the grout pump pumps under pressure the grout or the flushing medium, which is a thinner grout, so like a 70 to 30 water cement ratio. So it pumps that flushing medium through the center of your bar while you drill. The drill bit has holes. During drilling, there is percussion if needed, but mainly torque and rotation. And with that, you basically pump the flushing grout out of the holes in the bit, and with the rotation, basically your borehole widens depending on how soft your soil is. The softer your soil, the wider your borehole. And the pressure is so high that actually the flushing grout with your debris comes out of your borehole at the bottom. So you will see that it looks, in the beginning, looks very messy, but the deeper you drill and the further you go, the cleaner basically your flushing medium becomes. And that gives you also an idea if your borehole is completely flushed out, because that's what you want. If your borehole doesn't flush out properly, your grout body is a mixture between cement grout and soil. And then you don't get the MPA that you actually need from your pure grout.
Okay.
One more question is, I have a client that has, it's also an open pit mine, but it has very, very soft soil. They call it talc. So it's a white powdery material. Will a Titan work in there, or don't you think it'll work there?
It should, but what I would suggest is that that we discuss it. I mean, our mining experts are sitting there, so I think maybe that warrants a bit of a deeper discussion where we can see exactly what it looks like, what the site looks like. But strictly speaking, it should work, because you should be able to drill with a Titan and use a cement grout at the same time.
Thank you.
Okay, there's a question earlier from a colleague. Okay, I see your hand. There was a question from a BMK consultant. Janil, one of your colleagues is here, and he was supposed to ask a question. But I'll come to that question. Let's get this young man to ask his question here. In the center, middle, yeah.
Thanks. Thank you for the event as well. I think it was very well run. Thank you so much to Maccaferri. My question is for Mr. Jacobs, but it's open to the whole panel. I just wanted some clarity in terms of the solutions that we have in terms of the systems. I know we have the simple and we have the secure drapery system. You mentioned that we can have a combination of the two. What scenarios would you identify the need for a combination of the two, and what are the benefits of combining the two? Is it a cost-based benefit, or is there some other things that we can benefit from?
Wow, good question.
Okay, good question.
I'm happy that the question is for you.
No, that's fine. So some examples of a combination, and we've seen it sometimes actually in open pit mines, where they use a drape net and a barrier at the bottom. So this comes with a host of benefits that mainly is due to the risk factor involved. Because with rockfall, ideally we should have 0 failures in rockfall. So we always, you know, the Euro code, we always overestimate the acting forces and we reduce the resisting forces. So we try to get higher safety factors on this, and in some instances, a combined solution is preferred just to mitigate the risk completely.
Thank you.
And well, obviously, you know, engineering solutions come at a price. How do you navigate price with the engineering solution where you have multiple solutions?
Look, it's general project management, right? You know, quality, time, and cost. Sometimes if you reduce the quality, you reduce the cost, but if you increase the quality, you increase the cost as well. But at Maccaferri, we try always to find the most efficient solution, if I could say, So we do multiple iterations, multiple variations on the product and solution offering to try to get to the most optimal solution from a quality, time, and cost perspective.
Okay, excellent.
And also the cost depends on the country where you are. Because when you have low labor cost, some solution can be more cost effective in one country compared in some other countries. So it's difficult to give a general, it's a customized solution each time, depending on where the project is located, which are the labor cost. We have seen the project in the mine. They don't have any possibility to use cranes, helicopters. Everything is done by hand. In some other countries, it's impossible to do this because of cost of the labor. Okay, so it's always a balance to find between the effective cost of the project and the solution that you propose to the customer.
And I think that has a lot to do with trusting the engineer. Trusting the engineer and the solutions that comes out of the engineering team. Sometimes the cost does not matter because there's lives involved. I mean, cost always matters, but you've got to trust the voice of the engineer. So, okay. There was a question I wanted from the BMK. Yes. Would you pass the mic on?
Okay. My question is taken by the colleague. We actually discussed it on the soft ground, which is already being answered. But maybe let's ask this one, especially to the business development. Forgot the name, gentleman in there. I hear the product, I hear the costs. The localization, you said the country. By the way, my name is Fanny Club. I'm from BMK Group. It's a diverse business in engineering, property development, logistics, technologies, some of the other things we do there. But my question is a local content. Is the approach you are having in different countries where you are operating? The product speaks for itself and the solutions you are offering. I listened with great interest. How do you get to the market penetration? You see, people do business with people. You've got the solutions themselves cannot get to the client on their own. I'd like you to share those strategies with us. How do you do that market penetration and your strategies that are there? Price is something else. Product is something else. Solutions. I like the answer where it's flexible depending on the cost, depending on the needs of the client, fit for purpose, or you pay high price for the quality. I hope my question is clear.
Yes.
So it's more on your CRM and business relations side of things. Thanks.
I'm not so clear on the question, but I just want to confirm it's about...
Essentially, it's you've got fantastic world-class products that work well. How do you get that to market?
Okay, so
technical support is the first way to get to the market.
Yeah, so there's a number of things that we consider when we're considering the channel to market. One benefit for us from a drapery mesh point of view, I don't think we can put all the products into one class. We have to do it by product, by sector, by application. So by product, if we're talking about our steel grid drapery netting, that is locally manufactured. So the locally manufactured products are a little bit easier because, you know, with our government, it demands some sort of local content requirement. And then with the barriers that we're importing from Italy, actually in South Africa, there's no capability of manufacturing these kits. And we actually don't really have South African standards pertaining to rockfall barriers. So that's why we consider the Euro certification and the Euro standards. So with that product, we'll have to apply for like local exemption and things like that. So that's the strategy for two different products. But also, it's also by sector. So the mining sector, we'll have to consider where's the risk, where's the need. The type of support that we can offer to our clients is essential. At the end of the day, I think Maccaferri prides itself on being a technical service provider more than a product seller. So especially with rockfall, we prefer to be involved from the onset, from the time of feasibility going into the design phase, so we have an added value to the project value chain completely.
Yeah, actually the technical support is the main, let's say, way we use to penetrate the market, because as Blaise said, we are not selling material, we are engineer, and this is the technical support that we use usually open the door to the project and to penetrate the market, because we work side by side with the engineers, with the designers. So this is an added value for our activities, and it's important for us to have this kind of approach to the market.
And I'd imagine getting the word out there, like hosting a Maccaferri in Indaba.
Yeah.
Okay, I'm going to take one more question from our colleague. Yes, there you go. There's a hand up in the back.
Thank you. My name is Masara Nerufura from Finch Diamond Mine. I am a geotechnical engineer. So my question is, it's going to be a little bit short and longer at the same time, but maybe I was sleeping. So you guys are here, you mentioning a good process of the installation, quality control, when the guys are installing that, they have a good support from the team, right? And you have done a testing of the material where you ensure quality of the material. But I don't hear the quality assurance after the installation. Because if you're looking at open pit support, and then also looking at the road support, there is a challenges that I'm looking at and then think of. Because if you look at the blasting of your high wall, there is a fracturing that extend into your rock mass, the in-situ rock mass, and then also there is propagation of the blasting. So are you considering that when you advise the team of the length of the anchors that installed? Because I hear the guys, they mention a different length of the anchors used at the crest line, and also mentioning that the other two mentioned 3 meters, 5 meters, 2 meters, because if now you're looking, including the climate, and then your ground will start deteriorating, and because considering that the water will start infiltrating into the open cracks, so then can you ensure the lifespan, standing time of the support that have been installed? Are we looking at that, or are we just doing it for now, and then we'll say, okay, we'll rehabilitate it later on?
Okay, awesome question. I want to clarify, do you mean quality assurance during installation or post-installation, or both? Both.
Post-installation,
okay. Thank you very much. Let's start with Ansha. Yeah.
Thanks for the question. I think it's very relevant. The problem is that you get a lot of flight-by-night contractors that think they can do installation of products, but they're not really qualified. So with European standards being in place for, I'm just naming a few, like you have specialized geotechnical works for ground anchors, for micropiles, and for soil nails. With those three, for instance, it's not just a requirement for your material, but it's for its installation, with installation protocols, and post-installation testing. So for instance, with your SANS 54199 for micropiles, they specifically require to follow a certain protocol for each installed anchor. That protocol must be filled, the time that you need to install the anchor, if you have any blockages, if there were any breakages or stops. So everything must be protocoled, and a certain percentage of all working anchors, I'm not talking test anchors, but working anchors, must be subject to pull tests after setting time of your grout. And only if that is all in place, the client should actually take the project and say it is done correctly. We had, for instance, a case in the industry where anchors failed. So we could, or the contractor could basically go back to the specific anchor number, pulled the protocol and could see exactly ABC was adhered to or not. And it was found that the borehole wasn't flushed properly. So there was a lot of soil mixed with the grout. The grout didn't have the required MPa of 35. And that is why that anchor failed. If you don't find anything else, and you suspect, for instance, that the material of the anchor that you installed is not correct, your supplier should actually have a quality system in place that can actually tell you that is a batch number that you received, that failed anchor belongs to a specific batch, and that batch could be actually referred back to the supplier, and the supplier should be able to pull all the internal tests that were done on that specific batch by a third party. So these things should all be in place, and they actually by regulation should be adhered to.
Leonardo, you talked about standards earlier. I don't know if this question does relate to you. Could you touch on something similar in relation to post-installation?
No, actually, every single material that we have in our portfolio, every single solution is equipped by an installation manual. So we give guidelines to follow by the contractor, and inside this guideline is written how to install properly the material to get, let's say, the maximum efficiency from the material. After the installation, actually, we usually, let's say, are able to sign some documentation, some documents of correct installation of the material, but the responsibility of the installation is not usually on our shoulder. We can test, we can check that the material are correctly installed, but actually the operation made during the installation are not, under our responsibility.
For our material, we have some maintenance guidelines also after the installation. Of course, when we are talking about anchors, which are grouted inside the soil, it's very difficult to assess also the. I understood under the question also the risk of damages due to blasting close to the anchors, which might create some micro breaks into the grout and things like that. I don't know. I'm not an expert on this. But how to assess this, honestly, I don't know. In the long-term period, I mean, what are the consequences? Maybe an interesting study case for the young engineers here in the University of Johannesburg.
I want to bring an analogy for our audience that relates, but it's simply an analogy. The reason we have a pothole problem or electricity problem or water problem in South Africa, it's largely because of operation and maintenance. Now, I'm asking, what is in relation to that question, what do we do in your game to ensure that you don't have potholes in your game?
So look, I think at the end of the day, the products are certified, okay? The installation guidelines and manuals are there that are provided to the contractor. We try to be on site as well, more often than not, to make sure that all the boxes are ticked. But apart from that certification, you also have to trust your engineer, as you said previously. So as you design a structure or a bridge and you take liability on it, you sign an engineering certificate for it. Maccaferri also have a team of professional engineers. We also partner with third-party geotech specialists who are able to carry the liability on the design. So if you're talking about the post-construction design life, if we are carrying liability on it, obviously we will design according to that. So you have to trust your engineer, and I mean, if we signing the liability on it, we're not going to put something in that fails. We're obviously going to do our checks and due diligence to ensure that the lifespan is correct.
Excellent. Well, ladies and gentlemen, thank you very much, Ansha.
Thank you.
It's been a pleasure. Leonardo,
thank you.
Blaise,
Fabian?
Fabian? Yes. No, I thought you had something to say.
No,
Fabian?
no.
Je suis content de connaître. Merci beaucoup.
Merci beaucoup.
You can leave the stage.
Okay.
Yeah? Thank you. Thank you very much.
Thank you.
All right, ladies and gentlemen, we have come to the close of our day. Thank you very much for your patience, and I hope you have gleaned a lot of information. I certainly have learned a lot about the company Maccaferri, together with the services that they offer. And I look forward to seeing you tomorrow morning, bright and early. Thank you very much. Travel safely if you're driving on the roads.